Okay. So I'm pretty sure people are still lost on campus. But anyway, for those of you that have made it successfully, welcome. I hope you had a nice journey and we're ready to go. Okay, I'll be very short and brief this morning. Welcoming address by the chair. Oh, by the way, I'm Giuseppe. You probably know my name through emails and things. Proper welcoming address will be given tonight before the evening gigs. Okay, so today we go straight into the paper session. That's because all the other chairs are lost around campus helping out with installation and other parts of the conference. So, yeah, welcome to ICLC. We're ready to go. 3 days of intense works, presentation, workshops, and concert, especially the concert on Friday, which is going to be a 26-act gig. That's going to be a tough one, but we'll try it. We go with that. We'll make it kind of in a communal spirit. We're going to make it. We're going to do it. So, off we go with our first keynote speaker. I'm delighted here to open ICLC 2020. Hey, Alex. Hey. is Emma Cocker. So I'll introduce Emma, and then Emma will address an opening with her keynote. So Emma Cocker is a writer, artist, and associate professor in fine art. Operating under the working title Not Yet There, Emma research focuses on the process of artistic endeavor alongside model of art practice and subjectivity that resists the pressure of a single stable position by remaining willfully unresolved. Her mode of working involves an interdisciplinary, hybridized approach that unfolds restlessly along the threshold between writing, art, including experimental, performative, and collaborative tactics for producing text parallel to and as art practice. Emma was invited for her work, of course, for her prestige, and also because we found her work very interesting, especially for the idea of kairotic and kairos, which I'm pretty sure she's going to explain today to you. But it's, I think she nailed it at the core of one of the issues in the live coding community, which is that necessity, that need to have the computer being able to respond to your command, has some kind of semantic usefulness and understanding, but at the same time mediating that necessity with the second necessity in this community, which is having the computer kind of acting on its own, or if not acting on its own, to be unpredictable, no? And the kind of use we make of random function. So, beside that, also I share with Emma a passion for Foucault, and that's it. So please welcome Emma Cocker.
Well, firstly, it's a real delight to be here. Thank you so much, Giuseppe, for the invitation. It's really great to be here and great to see you all this morning, which feels quite early, actually. I've got a little bit of a cough, so bear with me a little bit. Just have a... Okay, so I first encountered live coding in 2012 within the frame of a research project called Live Notation, Transforming Matters of Performance, led by live coder Alex McLean, working with live artist Hester Eve. So I'm not a coder and I'm not a musician, but there was something about the quality of thinking in action that I could visibly witness within live coding that really struck me as distinctive, that seemed to have both political and also philosophical resonance. So over the last years, through involvement in further research projects such as Weaving Codes, Coding Weaves, as well as through working together on a book project on live coding with Alan Blackwell, Jeff Cox, Alex McLean and Thor Magnuson, I've been attempting to try and give some articulation to this sense of thinking in action, as well as to the qualities of liveness, aliveness, even of lifeness that might seem to be present within live coding. Underpinned by the principle of performing its thinking through showing the screen, live coding makes visible the process of its own unfolding through the public sharing of a live decision-making process within improvisatory performance practice. To expose the inner workings of a practice foregrounds the process itself, emphasising the durational taking place of something happening live, the activity of working with and through obstacles or of figuring something out. The liveness of live coding seems to be exemplified by the just-in-time or on-the-fly nature of its improvisatory extemporizing, its performing and showing of live thinking in action. However, my own interest is not just in how live coding performs thinking in action, showing its thinking as a live event, the making visible of the work, but also how it performs thinking in action, where the specificity of its thought remains immanent, not anterior to the performance itself, where thinking emerges in, with, and through. The thinking in action within live coding takes place in, with, and through the materiality and mediality of the performance itself, an embodied mode of intervention and invention in the middle, based on timing and timeliness. In other contexts, I've reflected on live coding as a kairotic practice, as kairotic coding, drawing specifically on the ancient Greek rhetorical term, where kairos is often taken to mean timing or right time, a decisive critical moment whose fleeting opportunity must be grasped before it passes. Here, kairos can be conceived as both a temporal opening or a critical moment, a nick in time, and in rhetoric scholar Eric Charles White's terms, a will to invent, capable of responding to this opening. He says, kairos thus establishes the living present as a point of departure or inspiration for a purely circumstantial activity of invention. So for White, understood as a principle of invention, kairos therefore counsels thought to act always as it were on the spur of the moment. He states, kairos stands for a radical principle of occasionality, an improvisational capacity that is contemporary with itself, alert and able to adapt to the present occasion. So in these terms, kairotic improvisation, perhaps kairotic improvisation within live coding, involves surrendering to the contingencies present within each new situation, letting go of or even loosening attachment to any preconceived ideas or plans that might have been made in advance. So there's also a different accentual form of the term kairos found in the work of philosopher Antonio Negri, who uses this term to describe a mode of eminent and imminent invention taking place at the limit of being. He says kairos is the modality of time through which being opens itself, attracted by the void at the limit of time, and thus decides to fill that void. So Negri conceives of this limit experience of kairos as being on the brink or being on a razor's edge, a point of opening and of necessary decision. So he designates the term kairos to a kind of restless instance, if you like, where naming and the thing named attain existence in time, for which he draws an example of the way that the poet vacillating fixes the verse. So following Negri, a kairotic practice might be one that's alert to the live circumstances of its own production, capable of creating the conditions for, whilst at the same time simultaneously responding to, the contingents within its own emergence. So Negri states, kairos is just this, the moment when the arrow of being is shot, the moment of opening, the invention of being on the edge of time. So unlike some computer-generated performances that involve the activation of an algorithm conceived in advance and simply let to run its course, within live coding, running algorithms have the capacity to be interrupted, rewritten, and their course changed. So rather than giving over responsibility to an algorithm's logic, within live coding, the performer consciously adopts a medial position, actively maintaining the conditions that will keep the unfolding of action dynamic. The coder navigates a course of action by intuiting when to yield to the rule or code and when to assert control, when to respond and when to interrupt. So here, different pressures compete for attention as the force that gets things going gives way to another that allows things to continue. Here then, rhetoric historian Deborah Hawhey conceptualizes the medial position of invention in the middle as a kairotic movement involving the simultaneous extending outwards and folding back. It is a space-time which marks the emergence of a provisional subject, one that works on and is worked on by the situation. So here, the opportunity of kairos requires the perceptions and actions of an individual capable of seizing its potential through inventive means. Jorge argues how a kairotic practice necessitates a sense of immanent awareness, embodied thought in motion, and instinctual bodily capacity for instantaneous response. So more than a logical or purely conceptual procedure, kairotic coding involves this sense of embodied awareness, where principles of knowing how and knowing when are privileged as much as knowing what. Phenomenologist Max van Manen distinguishes several modalities of thoughtful knowing that are non-cognitive: actional knowing, situational and thingly knowing, relational knowing, and corporeal knowing. He states, "We experience our knowing how and what to do through our actions, through the situations in which we find ourselves, through our relations with others and the world around us, and through our embodied being or corporeal existence." So indeed, there's definitely an inherent physical, kinetic, even kinesthetic dimension to the live writing of code, a movement vocabulary of micro-adjustments, changes and shifts performed in the frantic shuttling of the cursor around the screen, in the flashpoints of activation and execution. Analogous to the pulsing live body within other forms of performance, the flashing cursor marks the point of decision-making within the live programming of code, the movement of the coder's thinking as it oscillates between sense-making through the discontinuous, abstract, notational form of code and the continuous, even sensuous experience of coding as a lived experience. The thinking in action that is performed within live coding is multimodal. The linguistic, numerical, computational logic combined with the musical rhythmic know-how of a more tacit or even embodied kind, involving the tactility of active exploration, even haptic perception. So as you all know, live coding is extended beyond the performance of computer music and projected visual effects, expanding rapidly to embrace practices, especially from live art, performance and choreography, that foreground the potential of code in explicit connection with the performing body. In recent years, a number of research projects and symposia have attended to the live interactions between body and machine, the navigation of various human and non-human forces and flows, and to the specificity of liveness in embodied thinking in action. Consequently, as the field expands, so does its frame of reference and conceptual ground, with the issue of liveness rethought through the prism of somatic practice, affect and embodiment theory, drawn from choreographic studies, perhaps even reflecting a wider choreographic turn within contemporary culture, where notions of embodiment, performativity and corporeality, alongside philosophies of movement originating in dance, have increasingly entered the expanded interdisciplinary field. Yet, to foreground this sense of liveness does not involve the valoration of spontaneity and originality as indicative of authenticity. Philip Auslander has long since complicated any clear distinction between the live and mediated performance, arguing that the very concept of liveness emerges in and through the relation with its perceived opposite, mediatization, rather than having any preceding ontological condition or existence. So within media culture and performance studies, the concept of liveness has actually been very much contested, inflected at different historical junctions in relation to wider questions of presence and absence, mediation, recording and documentation, eventness and nounness, ephemerality, temporality, contemporaneity. In the publication Experiencing Liveness in Contemporary Performance scholars Matthew Reason and Anya Moller-Lindelof call for a re-examination of the concept of liveness, moving beyond contested questions of ontological difference and the relationship between the live and the mediated to focus on liveness in terms of processes of experiencing, processes of making, and processes of audiencing. From liveness, then, to multiple and shifting livenesses, and to the different pluralities of experiencing live, acknowledging the different meaning and value that liveness holds across different disciplines, including music, performance, and media studies. They note how bodily co-presence between audience and performers is central to performance studies. Music studies have typically engaged with liveness in relation to recording techniques and sound ideals. Within media studies, liveness has been discussed in relation to transmission technology. So it's interesting, I think, that live coding exists at the interstices of these various different disciplinary domains, in turn activating their different attitudes towards liveness. So within live coding, liveness refers to both non-human machine liveness, or degrees of liveness, articulated by computer scientist Stephen Tanimoto as the increased immediacy of semantic feedback and real-time character of computational processes enabled through technological advancement, but also, importantly, and the contingencies and vitalities of embodied live performance. So these differences seem to give rise to diverging expectations and aspirations for the liveness of live coding. On the one hand, there seems to be a call for improved media technologies, enabling greater immediacy of semantic feedback, supporting a faster, more fluid, perhaps even virtuoso approach to improvisation. Alongside, there remains interest in the live coding community for a mode of improvisational performativity that harnesses the liveness of the unpredictable, the unexpected, and the as yet unknown. So whilst live coding is described as a mode of real-time composition, in reality there is a lag due to technical latency between the writing of code and its execution. There is an inescapable delay in the feedback loop between the action, the writing of code, and the effects of code's activation. Feedback is non-immediate, such that within the live and present moment, the live coder is both attending to the unfolding of their live performance based on coding actions from a moment's past, whilst also setting up the conditions for what will come next. The coder's attention is split between the present of the present moment, or the as-is, and the future of the present moment, the yet to come. So this lag complicates the notion of liveness within live coding, because unlike other forms of live composition, the relationship between the performer's actions and the resulting effects is asynchronous, or rather there are parallel threads of arrhythmic liveness. The live, yet arguably no longer live unfolding of effects generated through the event of coding, and the live event of code writing itself, both of which are simultaneously experienced by coder, performer, and audience. So whilst the kairotic nature of improvisation might be imagined in terms of swiftness and immediacy, its capacity for swift response, the practice of live coding navigates this temporal lag between a decision and its effects. So one issue for this field of practice could be to explore how digital technologies and the development of intelligent machines might better enable the improvisatory state of kairotic flow. One response to the problem of technical latency is a call for improved technological media technologies, enabling greater immediacy or timeliness of execution feedback, alongside reducing the scope for error, effectively making the performance feel more real-time, increasing the perception of its liveness. So again, for Stephen Tanimoto, liveness involves minimizing the latency between a programming action and seeing its effect on program execution. It is a question of the temporal relationships between programmer actions and computer responses. So, as many of you know, he conceives of this hierarchical system of liveness, levels of liveness, which move from level 1, where there's no semantic feedback provided, to level 4, described as informative, significant, responsive, and live, where incremental semantic feedback is automatically provided. Here, the computer wouldn't wait, but would keep running the program, modifying the behavior as specified by the programmer as soon as the changes were made. So he also elaborates 2 further levels of liveness, arguing that in level 5, tactically predictive, the computer not only runs the program and responds, but also predicts the next programmer action. Instead of the environment lagging behind or just keeping up with the program, it stays ahead of the programmer. And in level 6, this further involves intelligence inference of the programmer's intentions and desires. So there's this kind of movement from kind of non-semantic feedback to a fully predictive, even anticipatory form of programming. So technical developments such as this promise human-machine interfaces and improvisation that have been improved, with predictive coding supported by faster response and processing times, seemingly maximising the potential for kairotic flow, for increased spontaneity, for more immediate coding on the fly. So rather than a passive tool, the computer is afforded a degree of decision-making responsibility based on its capacity to second-guess, to preempt, or even predict the next step within a creative flow of action as it learns more about the performer's tendencies and preferences. Yet, technological advances don't always give rise to inventive forms of improvisatory liveness, conceived as a mode of live thinking in action, of real invention and intervention. Indeed, the pressure to perform, even entertain, within certain live coding performance contexts places high demands on the performer. So under these conditions, technical developments risk becoming instrumentalized at the service of technical virtuosity through reducing the potential of error alongside increasing the performer's capacity for repetition of complex sequences of coding. Here then, speed and immediacy might become mistaken for liveness. Increased efficiency might lead to less waste, which might in turn result in less risk. So, how can live coding offer a subversive alternative to, perhaps even a critique of, the certain utilitarian technological developments, which in privileging efficiency and optimization might risk limiting creative possibilities, reducing the possibility of human intervention and invention in the seizing of opportunity, accident, chance and contingency? Indeed, as White asserts, the impulse to repeat, which ratifies the comfortable notion that knowledge is in principle finite, encourages us to speak not to the present moment, the locus of genuine novelty, but from or in imitation of the purely ideal constructs of our memories. So a kairotic practice, differently from that, involves responding to each situation anew, rather than based on responses that are already rehearsed and in waiting. Kairos is a contingent form of working knowledge, not based on knowing how to deal with a situation in advance, but rather it is a form of knowledge born of the moment, from having the confidence that the right decision will be made when requires. It involves trusting that a response will be performed appropriately and with skill at the propitious time. So like many other improvisatory practices, live coding involves experiential grounding in a temporal present, whilst remaining alert and receptive to opportunities of an unfolding future. Drawing on the philosophical work of Catherine Malabou, Jean-Luc Nancy and Jacques Derrida, writer theorist Jean-Paul Martinon asks, how do we address the coming of the future? Turning to the French language, Martinon identifies two different words for future, le futur and l'avenir. The first, le futur, refers to something distant or remote, possible or probable. Le futur supposes, in fact, the possibility of projection, predictions, and prophecies. So whilst le futur is concerned with what will or might be, l'avenir, as Martinon notes, is usually translated as what is yet to come. Though different, both models refer to the future as a linear continuation of time, whereas Martinon notes time is always one-dimensional and unidirectional. It goes forward into the future. So against this logic, he tries to reinvent the term futurity by drawing on the radical potential of a third term, avenir, the expression of the to come. For Martinon, avenir represents an unhinging, a spacing and temporizing which interrupts the present, breaking up the measurable linearity of space and time. According to Martinon, avenir surges between the foreseeable, the projectable, the plannable, the programmable future present, and a radical future, that which exceeds or is more than this future possibility. So the concept of avenir refers to a kind of gap or creative interval between the as-is of the future conceived as a continuation of the present, between the as-is of the present and the not yet of the future, but not the not yet of the future conceived as a continuation of the present, but rather that of the to come. So for some live coders, enhanced technologies might enable increasingly plannable futures where decisions are anticipated to support the efficiency, immediacy, and speed within performance, whilst arguably for others, the futurity that live coding seeks to harness is oriented closer to a model of kairos or avenir, the leaning into the void of the to come, where the unfolding future of the performance emerges simultaneously to its activation. So rather than view these two tendencies in antagonistic relation, I'm interested in how different notions of liveness are being played out within live coding. And the question, how can the development of intelligent machines better facilitate live coding's liveness without eradicating the critical intervals and in-between spaces that seem necessary for improvisatory invention and intervention, without smoothing away the points of technical resistance and intransigence, which arguably form part of live coding's performative texture. So, one question might be, how might technological innovation enable a heightened level of collaboration or co-improvisation with machines that allows for the emergence of the unexpected by combining increased performance capacity with a continued embrace of risk and uncertainty, error and failure? Indeed, how might predictive technologies, perhaps counterintuitively, enable that which cannot be predicted in advance, a truly experimental and surprising mode of improvisation, made possible through a more intuitive collaboration between human and non-human? Alternatively, rather than view the lag or latency within coding as a problem or as a deficiency that needs to be reduced or solved, is it possible to conceive of critical potential within these interruptive intervals? It's tempting to focus on the just-in-time nature of live coding's improvisational decision-making as one that is necessarily connected to speed of thought, urgent in the now of the present as it is seized. However, the performance of timing and timeliness within kairos is not performed in haste, but also relies on the dual principles of slowness and speed. Paradoxically, perhaps, the critical opportunity within the opening of kairos ready to be seized might only be discerned through a slowing down of habitual rhythms and flows, thereby producing the necessary quality of attention. Indeed, for some thinkers, the loss or eradication of thresholds and intervals results in an impoverishment of lived experience. So according to philosopher Byung-Chul Han, today's experience is characterized by the fact that it is very poor in transitions. He specifically notes how technological possibilities for recurrence destroy the temporal interval which is responsible for forgetting. They make what is past instantaneously retrievable and available. Nothing can evade this instantaneous access. For Han, against the eradication of intervals that creates a paradoxical present with no duration, he argues for a need for in-between times, for the time of waiting, since intervals not only delay but also allow us to linger. In these terms, what might become lost in the eradication of technical latency, in the quest for a speedier arrival at the intended result, or you could say, how is the gap or interval actually necessary for live coding? In one sense, live coding makes visible the interval as an active, expectant state where the working decisions or working out are shown almost synchronous to execution. Live coding shows the deliberation as something is being worked on, those threshold moments before the decision to act or intervene, those indeterminate spaces of doubt or hesitation, the movement of thought and fingers between this and that option. It shows the time that thinking in action takes. Yet, the thinking in action performed live and made visible shows something beyond its linguistic or methodological content. Here, following philosopher semiologist Paolo Verno, one might even argue that what really counts is the act of enunciating and not the text of enunciation. In Epistemologies of Aesthetics, media theorist Dieter Mersch asks what thought in other media might mean, where thought is understood as a practice, as acting with materials, in materials, or through materials, or with media, in media, and through media. For Mersch, artistic thought reveals itself in the form of those practices that work in the work, the becoming of the processes themselves. He argues that the decisive epistemic modus through which art performs, presents, and exhibits its work in the work is always one of showing. He says, we are dealing with showings that in equal measure reveal something and show themselves, whilst in showing hold themselves back. Their métier is not representation but presence. Additionally, for Mersch, aesthetics focus on the singular, the this, here, or something that can be shown. It is never clear what it is, only that it is. So conceived in this sense, the performative action of showing the screen within live coding might be considered less as a device for revealing to an audience what or how something is unfolding, but purely that something is unfolding. The revelation of artist thought in action with, in and through the mediality and materiality of the performance itself. For performance theorists Erin Manning and Brian Masumi, thinking's in the act or thought in the act refers to the immanent movement of thought as it is performed, not a knowledge that is bankable or transferable, but rather one that is acquired through practice, moreover activated only in and through the practice. They differentiate thought in action from the if-then logic of habitual thought in action, where in habit, the body moves into what today's situation has recognizably in common with yesterday's. The meaning is always adaptive. This repeated sequence fits the general situation as it did before and will again. So against repetition and the contracting of habit, they argue for reactivation. In these terms, what is performed is qualitatively closer to the immanent intensification of thinking that Alain Badiou, following Nietzsche, asserts is not effectuated anywhere else than where it is given. Thought is effective in situ. It is what is intensified upon itself, or again, it is the movement of its own intensity. So this mode of knowledge as intensification refuses commodification, which is all too easily reabsorbed by capital. As Alan Pottage states, its power exists only on act or in actu, which is to say, in language closer to Spinoza, that it is only in the process of its exercise. So whilst my own conceptualization foregrounds the principles of kairos, timeliness, and also its attendant intelligence, metis, cunning, or wiliness, this is not to say that the thinking in action is something that a human subject does. I'm interested in thinking in action as an embodied, rhythmic, immanent practice where the thinking is not conceived in advance, but rather emerges live to the situation. Moreover, that this thinking in action is co-emergent or co-produced through the interrelations and interdependencies of different forces and agencies, the interweaving of different resistances and pressures. Indeed, the subject herself is not only shaping, but is in turn shaped by the process of thinking in action. In this sense, I'm interested in how the performing of thinking in action within live coding might be conceived as a contemporary form of melet, an ancient Greek term used to describe a meditative thought experiment or exercise in thought, especially undertaken as a preparatory practice for supporting other forms of critical, even ethical, action, agency, and subjectivity. In his late work on the care of the self and hermeneutics of the subject, Michel Foucault observes how in ancient Greece there were a number of terms which roughly translate as meditation, referring to the philosophical exercise in or practice of thought acting on thought. For Foucault, the process of melet involved a mode of internal reflection, which the preparation of thought on thought, of thought by thought, which prepares the individual to improvise. So conceived as a kind of melet, the improvisatory process of live coding might be disentangled from the telos of performance and considered more as an end in itself, a site for practicing the relation, for example, between spontaneity and receptivity, between yielding and control, between the agency of the self and external forces, between an immersive flow experience and split attention, between human and machine. Live coding can be approached as an exercise of thought in action for practicing heightened attention, a sense of qui vive, alertness, vigilance, or watchfulness, for attuning to the temporal experience of presentness as well as the atemporal, for developing an ethical and elective rather than obedient relation to the rule, for working with limits as points of creative leverage rather than control, for converting chance and contingency into opportunity, for nurturing both a sense of aliveness and also lifeness, sensitivity to the experience of being in the midst of life. So herein then might also reside a further sense of live coding's political, philosophical, and perhaps even ethico-aesthetic potential. Thank you. So the paper's drawing on a number of articles and sort of weaving them together, but if you're interested, they are available online as well. It's perhaps also worth saying that I'm in the process of working on a new publication called Being in the Midst, Performing Thinking in Action, which looks at a wider spectrum of practices from interdisciplinary perspectives, of which one practice is live coding, where the performing of thinking in action is a critical part of the practice. And over the next days, I'm really interested in having conversations with people if they're interested in that. Thank you. I don't know if there's time for questions. Okay.
We actually have 10 minutes, 5 minutes, 5 to 10 minutes for questions. With 90 hours.
Hello.
So Emma, you mentioned that a bit earlier on. You said that part of the practice is not so much about the what is happening, but that it is happening.
Mm-hmm.
And I guess, can you reflect on what that means for the staging of a live coding performance and the way that we do? Obviously, this is kind of a big, in some ways, a key question for the live coding community. How do we best show what's going on? What do you think that this stuff, the implications are for the way that we do stage and show what we're doing versus hide things under the surface? I'm not sure if that's a very well-formed question.
I mean, I can talk about some of the things that have really intrigued me as I've encountered live coding performances. Perhaps that's a better way of doing it rather than saying it should be like this. I think one of the things that struck me most about live coding as a critical practice was the way that it sort of shows the backstage in a way. And one of the spaces of live coding that I'm especially interested in is this space of setup. Well, actually, in terms of all performance, I'm interested in how a performance begins and how a performance ends as critical thresholds, if you like. And live coding, I think, in some practices that I've witnessed, seem to be doing something really fascinating, because there was often this transition, or what you witness is the setting up of the conditions for a practice. And I think that's a really critical component of live coding. I realised that within the diversity of live coding practices that we have in the room and are operating internationally, that might not always be the interest of the live coder, and it might not always be present. But for my own interest, that's something that I was particularly looking at. So as someone who can't read code, I was also interested that there was something happening at a level of inquiry that I could tune into beyond an understanding of the content itself, and that there was something critical in this kind of making visible of process beyond simply showing to people who can read what actually is happening. I don't know if that answers the question or not.
I mean, I'm not really sure specifically what the question is, so that's really helpful. Thanks.
I mean, and in that sense, live coding also might be situated in relation to a whole spectrum of other performance practices, which are interested in dislodging the primacy of performance to critically reveal some of the working of the work that's happening, I think.
So I've got a question.
Yes, hello.
Hi, Emma.
Hi.
Thank you for this wonderful talk. It was really thought-provoking and interesting. I wanted to, since you have such a diverse background in the arts, and you're an art writer, you write as your artistic practice, but you engage with other fields of art and so on. I'm wondering about this timeliness of live coding, and this way of thinking in the live situation and projecting that or making it explicit to the audience that you're actually building, that you're thinking live. I get that argument very strongly in your talk, but can you see similar analog practices in the other arts? I'm curious, are there architects or are there dancers, choreographers, theater, like some forms of theater where people are actually building the work as on stage, live? Can you see any, or tell us about something
Yeah.
that is similar?
I mean, in a sense, actually, the book that I'm working on, to a certain extent, deals with that. Its focus really is on practices that perform the thinking in action, but ones that make it visible. So in a way, there's improvisatory thinking in action within all practice, but some of it is concealed in the hidden work of the work, if you like. So in a way, my initial interest in this was actually through drawing practices, and drawing practices which were peculiarly attending to the emergence of their own occurrence, if you like. So not figurative drawing, not drawing from the imagination, but a drawing practice that's very specifically tuning into the resistances and pressures of its own emergence. And this predated the connection that I had with live coding, or it was around about the same time. So when I was invited to participate in the live notation project, there was just this moment of seeing a practice which to a certain extent I was relatively unfamiliar with, and just witnessing something in that shared qualities with this other kind of live performing thinking that I'd seen in a drawing practice. But the thing that was interesting about live coding is that the quality of its temporality is quite different in a way, because in part because the action and the effect is not quite synchronous. And in that sense, there's something that happens in a really specific way within live coding that actually sheds light on the possibility of multiple temporalities, a kind of stretch sense of the present, this kind of activation of the past present, the present present, and the future present, this kind of three-part present that's talked about in phenomenology. And you think, wow, you can really see this activated in live coding. So drawing was one. In my own practice, some of the research projects that I've also been involved in have had the same kind of question, really. So in the last years, I was involved in a project called Choreographic Figures, which was a collaboration between myself. I mean, I'm from a fine art background, but I predominantly work with language, an artist who's a visual artist, and a choreographer. And what we were trying to do was to try and develop score systems through which to make visible the process of decision-making within collaborative improvisation. And we developed a notation system for this, basically. So our notation system involved clicks and audible signs that was trying to mark when decisions were making within the process. So this is kind of collaboration practices, if you like. I think there's also kind of a whole relatively recent phenomena of artistic practice, specifically through residency models, where the making of work takes place within a gallery context. So rather than seeing the product of artistic labour, the artwork, what you actually witness as the audience is the making of the work live in the space. So that this is another interest that I'm following at the moment. So it's evident in many places. In some ways, there's also an interesting dilemma in this, because the criticism of it, if you like, or the kind of, what would it be, the shadow of it, is that in revealing more of process, we reveal more that has the capacity to be assimilated by capital. That's certainly the big debate in process-based artistic research, that are we just making visible more of the hidden process that has the capacity to be assimilated and eaten up by commodity culture in a way. And I think there's a real sensitivity around that question. I think there's a real dilemma there, actually.
Thank you, Emma. Let me check the time, 1 second. Oh, if you have one very short question. Yeah.
Hi, thank you. This is really great. My one question, very quickly, is in thinking myself about interactivity in art. I work with this a lot, and I'm curious what you have to comment on the idea that if the interactive methodology here is between the performer and the algorithm or the automata, then what role does the audience have in that? Because normally when we talk about interactivity in the arts, it's between the piece and the audience, and something unfolding from that. And so I'm thinking a lot about where does this place the audience, what is the audience role, and what do they bring to it?
Yeah, I mean, I think that's a great question. I mean, many of you here, most of you here are probably performers, so I think no doubt you'd say that the audience is really critical. And I think that triangulation between technologies, performer and audience, I've not talked about it so much in this particular presentation, but I think is really a critical component of the work in a way. And in that sense, I guess, how would it work in terms of thinking in action? I suppose there's something to do with the way that the performer is responding between the audience and the space of the stage to a certain extent. In one of the chapters that we've been working on with, actually mainly with Jeff, but with Alan and Thor and Alex as well, one of the notions that was being explored within that was around performativity. And I think, again, performativity is an interesting concept because it has such varied and wide resonances depending on which interdisciplinary field you come from in a way. But certainly some of the debates around performativity from theatre and performance very much address exactly that this is a kind of contingent quality that is very much through the relationship between performer and audience, not just in the kind of Austinian sense of promise, that it's to do with a promise that's executed, if you like.
Surely.
So that was a bit of a rambly answer to that. But yes, it's important.
And I mean, for me, it's a question of, when you take that performative interactivity and you set it aside, does it become a spectacle that removes the agency from the audience in a way, instead of this idea of interactivity bringing agency to all the parties? To me, in some ways, it seems to separate. But
yeah, I mean, many of these terms are interesting because they're quite ambivalent in a way. So kind of interactivity across the fields, participation, collaboration, in a way, they're also buzzwords to a certain extent. I would argue that there can be kind of critical forms of interactivity and forms of interactivity that present an illusion of it but might not be it. Similarly for participation and for collaboration as well. My own interest would be very much in terms of what is the inquiry that's been turned over in this practice. What is it investigating really? What is it exploring? And for a practice to explore interactivity, I think is really different to a product that is professing interactivity as a way of being more inclusive or engaging, but without perhaps any sense of critical underpinning, if you like. Yeah.
All right, Emma. Thank you very much.
Yeah, thank you.
You stay with us until tomorrow, aren't you?
I'm here till Friday morning.
Until Friday morning, so plenty of occasion to chat more. Okay, so Alvaro. All right, so we're starting now with the paper session of this morning. So to the presenters, quick explanation how it's going to go. So 15 minutes, and then you'll see me having this pamphlet here. 5 minutes left, 2 minutes left, 0 minutes left. All right? And then we will have 5 minutes question. 5 minutes Q&A session, all right, for each talk. So we try to be strict with the time. So, first talk is titled Live Coding in Western Classical Music, and the speaker is Alvaro Caceres Munoz. Yeah.
Is it seeing it at all? Where's your display? Yep.
Great, thanks. Okay, hello everyone. Really happy to be here with you today with such a nice community interested in live coding on its many different aspects. In my case, I'm going to talk about live coding in the context of Western classical music. Expect to see lots of memes about Bach. I apologize in advance. Okay, so what I'm going to talk about is what I found to be something that could be improved in the context of live coding for classical music. I'm going to talk about the aims and goals of these projects. How did I try to achieve those? By designing, implementing, and testing some small programming language for live coding called backtracking. And finally, I'm going to share the conclusions that I arrived to. Okay, so first of all, the reason why I became interested in live coding is because I come both from computer science and from classical music. So at some point, I realized that live coding mixes really well the way in which we think when we are programming. So it's a really structured and logical way of designing software, and the way in which we think when we are composing music, for instance, in classical music or in jazz music, where we are using structures and transformations that are quite logical in nature, and in most cases algorithmic as well. And so I thought that live coding was like a perfect match for people coming from a classical background or any sort of style of music that is based on the Western classical music tradition. So I was trying to take a look at different live coding programming languages, which I found extremely interesting. I just found out that coming from classical music, it was sort of hard for me to wrap my head around the syntax or the terms that were being used. And so I was thinking perhaps this is a problem that more people in the classical music community may find. And so I asked myself, how can live coding be used in classical music? And so I tried to address several aims for this project that was starting to build on my mind. First of all, I wanted to understand really well which techniques of live coding could be applied really efficiently when we are trying to create music, if we come from classical music or jazz music. And also, I wanted to understand from a human-computer interaction perspective, how do classical musicians feel like when they are performing using live coding. So there's not necessarily, but traditionally, instruments have been known for being quite immediate, especially acoustic instruments. Programming tends to be planned. You tend to think beforehand, not in live coding, but generally speaking, it works in this way. So I was wondering, how can we mix these two interaction paradigms so that it feels natural for classical musicians? And so I wanted to test these ideas by creating a really small programming language called backtracking, pun intended, which tries to incorporate all these ideas I was thinking about, and which was, among other things, it was following a user-centered design methodology. So I was trying to take into account users' opinion both before implementing the system and after implementing the system. So really, basically what I did was to take a look at previous examples of programming, live coding programming languages. I designed how the grammar would look like and how the code would look like for the musician. And then both by taking this knowledge into account and by running some interviews with musicians, I tried to actually implement a small system, and then I tested it with those users again, running more interviews to see if they were happy with the end result. So what I came up with was a language which has a really simple syntax and which tries to look as similar to the terms we use in musical language as possible. So here you can see different examples of what the syntax in backtracking looks like. You can set the tempo or the time in a way that is quite straightforward, and you can schedule things not in terms of seconds, for instance, but in terms of bars or fractions of those bars. So you can use repetitions, which are written in the same way as we would do on a music sheet. You can use accidentals. I actually used a syntax for octaves that it's not normally used in. It's used in some examples of musical notation, but I actually drew that inspiration from the Lilliput programming language. But in any case, I incorporated that into the language. I tried to make the instructions really concise, because I realized that when you are live coding, it generates, I don't know if you've been in this situation, but it generates lots of anxiety on you when you are trying to type some code to keep the music going and you realize that you are already late, or you are kept inside of a loop for some seconds in some sort of awkward silence or awkward repetition. So I wanted to keep the amount of characters you use to type the instructions as low as possible. And then I also tried to design a workflow by which you try to write a small melody, then you apply some transformations to that melody, and then you store those results in variables for later transformation. And just for starting with this language, I included some transformations inspired from techniques from counterpoint, so inverse, retrograde, and then join, which basically combines two melodies together, and mirror, which basically mirrors the melody. Also, I proposed a different mental model of a score. Again, I'm using a lot of terms that come from UX and human-centered interaction, because that's the branch of computer science that I come from. But basically, I was thinking of this programming language also as a mental model, and I tried to design it as a score where you can type stuff on your text editor, but all those things you are typing don't mean anything to the music unless you upload them somehow to a score, a live score, which is linear in time in the same way as a normal music sheet would be. And for the UI, it's a pretty standard text editor with notifications, errors, so some sort of system where the user is able to modify the code and get some feedback from it. this is what it would look like, basically. I use Visual Studio Code for designing a really simple prototype. And interestingly, I use MIDI note input for allowing users to specify the notes with a musical keyboard rather than typing them on the computer keyboard. I'm not going to describe all of the things that you can see in this diagram, but basically the main idea is that I designed this system so that it was as modular as possible. Basically, you've got your input and output devices, which are based on MIDI mostly. So this programming language generates MIDI rather than proper actual sound. The reason for doing this is mostly that I was most comfortable working with MIDI rather than creating waves and signals myself. But also I thought it could be interesting because MIDI is a little bit more abstract, and it also allows you to export those instructions to your DAW of your choice, and so I thought it was more convenient. The button on the top is basically your text editor, which could be changed, and that's why I tried to mean with this diagram that everything should be as modular as possible. For evaluating this prototype, what I did was to ask six people coming from a musical background to try the program. So I used semi-structured interviews to try to get a more natural conversation with the musicians and also to spot some things or suggestions that I may have just not thought about. And that helped me to shape the prototype before actually getting the final implementation. And then I tested the product again. Basically, I gave the users a really short training on how to use this programming language. I led them to play for half an hour, 1 hour, and then I conducted another interview. And I got really interesting results from this. They got the syntax quite fast, which suggests that it was more or less similar to the language that they normally use to write scores. They found the tutorial that I wrote more or less straightforward, but they were losing where they were placed on the score because I hadn't included some system for feedback for telling them, hey, you are at bar number 57. They could specify where, in which bar to write the music, but they were not getting any visual feedback for that. So that was sort of a design error on my part. Also, they didn't quite get for how long would a musical motif last when they were writing it, and that's something that could be solved by using visuals. And I realized that professional composers would use the system more than students starting with musical education. Also, the syntax for octaves, which I drew from the lib and was sort of confusing for them. So, as I said, most importantly, I realized that this system could be most useful for professional musicians. I wonder, by the way in which it was used, whether if classical musicians would use this to actually improvise or to write music, because all the participants ended up spending some time to think about the music and then just running the whole piece of code. Feedback and situation awareness is extremely important in this case, because if not, musicians get lost in the code, as well as having a natural notation that is as similar to scores as possible. Now I'm going to show you a small demo. So this is a performance from one of the participants. Yeah, sorry for the bad name. It's a good friend of mine called Emilio Giraldo. You can check his social networks here. And the code is not running at the same time as the music. It's just a sped up process while he was writing the whole piece. Because I've said he actually composed this piece rather than improvising it. Anyway, I found it really, really interesting, so let's check it out. If we are getting sound. Sorry for that. Okay, now it's working. Sorry for that. That last Sema in the end was written with a MIDI keyboard, which was way easier than typing it note by note. Okay, cool. So really, quite briefly, I'm trying to expand this programming language in many other ways. Again, another back meme. So I want to have a graphical representation of the score, being able to connect this to your VST plugins, and making things as automatic as possible. For instance, if you're writing something for a string instrument, having some interfaces for your contact strings library and for any other library of your choice that would work regardless of the VST plugin that you're using. Implementing actual form and harmony, because as you may have realized, this is just pure counterpoint, or a really, really simple form of counterpoint, but I want to include harmony, voice leading strategies, constraints on, for instance, the pitch that your melody can take, for instance, microtonality as well. And also something really cool that I'm thinking of is to being able to type the instructions by pressing keys on the MIDI keyboard so that the interface becomes your MIDI keyboard, like totally, 100%. And having the two syntax modes, one that is easier to read and another one that is super compressed and more complicated to read but easier to type. And finally, I'm looking for collaboration, so if anyone is interested in this backtracking project, you're more than welcome to help. So, any questions?
Thank you.
Thank you so much.
Perfect timing.
No.
So we have 5 minutes, 5-10 minutes for questions.
Hi, thank you for your presentation. I just want to, can you clarify a little bit which is the live coding part from your language, or how live coding works in your language, in the sense of, can the person who is writing the code evaluate the functions independently so they can be testing like the different sections of the score, or do the the coder has to write everything and then execute it, and then at the end everything executes from top to bottom? So if that's the case, which is the which could you clarify which would be the actual liveness or of the language?
Yeah, sure. So thanks for the question. Yeah. So the thing is that we've got a score that is linear, but you can add things to the score and take them out at any moment in time. Of course, there are way more things that I should add to the language so that it becomes more live. But yeah, basically, the idea is that you can add things and delete things out of the score. And also, the score runs from beginning to end, but it doesn't have a specific end. Also, you can type things on the score, stop the score, start it again, similar to what you would do in a music sheet program like Sibelius. But yeah, it's alive in the sense that you can modify stuff. You cannot modify stuff that has been played already in the past, but you can modify the stuff that is going to be scheduled in the future. So for instance, if I want to type something for bar number 15 and I'm at bar number 3, nothing stops me from modifying that again in the future, if that makes sense.
Thank you.
Thank you.
Hi, thanks. I wondered if you could say a bit more about what your interviewees said in your interviews about how working with this tool compared to their normal composition practices.
So, well, thanks again for the question. So, music students have only written like really short pieces, composition pieces, so they found it weird, but professional composers found it quite powerful, especially those who came from a more, who were writing music, for instance, for soundtracks for films. So one of the people who were participating in the interview, he was used to use trackers or DAWs like FL Studio, and he told me that the process was really similar, only that instead of, for instance, clicking notes on a piano roll kind of interface, he was able to type more musical terms, and he found it more natural. So it was sort of mixed. Some people would find it a little bit weird, coming from a classical background, and some other people who had been more exposed to production techniques found it powerful. Of course, provided you got more techniques available, like harmony and all that. All of them complained about not having harmony, but yeah.
Okay, thank you.
Anyone?
Alvaro, similar to that question about the perception of the people who, your participants in the study, to what extent did they use the more programmatic aspects of it, like the, retrograde and inversion, the transformations and stuff, versus just, making a bar, playing it on the MIDI keyboard, making another bar, playing it on the MIDI keyboard, because you can do that with a piano roll editor as well, have keyboard input. What was the balance of the programmatic versus the direct input? Yeah. And what did they reflect on that?
So basically, again, it depended on the amount of experience of the user. So people who were almost starting with music education, they almost like 100% were using the keyboard the whole time and typing all the notes, to the extent that at some point it was just typing the notes on the text editor and then hitting the play button, which is a slow form of playing everything by yourself on the keyboard. But for composers, what they did was to type like a really, I don't know if you were able to see that on the code because it was typed really fast in this video, but what my friend was doing was to type a really small amount of notes directly, and then he was chaining maybe 7 or 8 or 9 different transformations together, again because he knew what he was doing and he had a more structured musical mind. Also, he used variables a lot, so he was repeating fragments, and maybe you were able to hear that in the demo. There were like small parts that were coming and going the whole time. So again, it depends on the amount of experience. That's what I found from the study. More experienced composers will exploit those techniques way more than music students, especially if they are on their first years. Thanks.
Right. Thank you very much, Alvaro.
Okay. Thank you so much.
Yeah.
All right, so onwards with the second presentation, titled Recoding the Musical Cyborg, presented Jake Witz.
Yes. Hi, everyone. I'm Jake Witz. I wrote this paper as an undergrad at the University of Wisconsin-Madison with the help of Dr. Reginald Royston and the HEXU Scholarship Program, although I'm here independently right now. I blog over at Goal Mechanics, which is my blog right now, for more thoughts like this. And I'm pretty online, so if I mention like the name of someone in here and you're in this room and I didn't realize it, I'm sorry about that. All right. The guidelines for hosting an algorithm posted on GitHub as a README file by Alex McLean cautions users against framing the event as a revolutionary practice. After defining an algorithm as a live music show in which most performances or acts should involve code-based and algorithmic generation of music and visuals, the guide advises newcomers that algorithm is not the future of dance music. We're just trying things out as part of a much longer history. Recently, and perhaps unavoidably, the history of algorithmic music, now commonly practiced with the aid of software, has collided with the history of digital algorithms which process data and people on a global scale. This is in part because algorithms coupled with computational power have the ability to execute processes far beyond the capacity of an individual person. In this way, algorithms have served to revolutionize the processing of data in the same way that mechanical tools once revolutionized the processing of raw natural elements. As such, whether by processing sound, consumer data, or social interactions, the digital algorithm has become a notable cultural medium for artists. The nature of how artists interact with algorithms, however, varies sharply between practices. Some musicians, like those who work within digital audio workstations like Ableton, use static algorithms as tools to produce a single desired output. Others use the algorithms created by streaming services like Spotify so as to better understand how they can shape their sound to increase audience engagement. Algorithms themselves now play a role in music as an aesthetic in and of themselves, as in the case of live coding, a musical practice which, as McLean notes, foregrounds the human authorship of algorithms and the fundamental musical activity at play. Algorithmic has also become an identity. Pop stars use the aesthetic of digital algorithms to generate hype surrounding their humanity or lack thereof. Even less forwardly, pop musicians collapse the algorithmic processes across dozens of actors, from streaming services to DAW plugins, into a single seamless product. I hope to convince you today that these aesthetic relations to algorithms can be understood as differently programmed constructions of the musical cyborg, a figure which combines human creativity and digital algorithms to create sounds and moments that wouldn't otherwise be possible through human production alone. In calling forth the metaphor of the cyborg, I do so according to Donna Haraway's reading of it in the Cyborg Manifesto as a cybernetic organism, a hybrid of machinate organism, a creature of social reality as well as a creature of fiction. The cyborg musician is both a creative and social construction. Its wiring produces sound while also providing insight into the social reality that produced it. This social reality, in a world shaped by black box algorithms developed by mega multinational platforms, is one where information processing is entirely opaque, resulting in a default cyborg relationship that fosters antagonism and deception between its receptive human and machine selves. Moreover, albeit on a smaller scale, black box musical cyborgs can conceal the humanity in their construction. This model extends to humans as well. Musicians concealing the algorithmic and collaborative processes behind their work promote the image of a single superintelligence. Human producers, then, are left competing with an invisible network of actors which manifest in these singular fictional forms. This seemingly bleak path, where black box algorithms are either producers for or producers of humanity, is not the end. Part of the reason the boundaries between human and computer production have been collapsing is because they've always been ripe for reconstruction. As Haraway notes in the Cyborg Manifesto, it is not clear who makes and who is made in the relation between human and machine. It is not clear what is mind and what is body in machines that resolve into coding practices. We find ourselves to be cyborgs, hybrids, mosaics, chimeras. There is no fundamental ontological separation in our formal knowledge of machine and organism, of technical and organic. Just as a cyborg's construction can represent the world from which it was born, so too can a gesture towards not yet realized futures through its fictive components. Because the machine is us, our processes, an aspect of our embodiment, Haraway continues, we are responsible for our boundaries. We are they. This we has become a case of contested ownership in the 30 years since Haraway published the Cyborg Manifesto between those steering the cyborg network towards optimized profiteering and those seeking to generate life within it. As Mackenzie Work notes in her retrospective of Haraway's work, it was prescient of Haraway to notice, and early on, that the new communications technologies are fundamental to the eradication of public life for everyone. The reduction of a wide range of processes, and not just labor, to a thing, or in this case to code, supports a vast extension of private property relations. The algorithms that undergird the musical cyborg now bear patents in code that make true interoperability a seemingly distant dream. In other words, those who have reconstructed the cyborg are those who have had the resources to do so. Later, I'll explore how these components found installed in art that is optimized for the streaming economy make it increasingly difficult to build communal knowledge. The more we accept this mode of algorithmic cyborging, both in and outside of music, the more hard-coded the network will become against any redistribution. The Algorave README constructs an alternate model dependent on transparency and the experimentation of algorithms, which in turn produces a new model for the musical cyborg. Though algorithmic music production takes many forms which vary in human agency, for this paper, I want to focus specifically on musicians within the practice of live coding, because live coders have a deliberate and intimate relationship with algorithms, especially among musicians. Moreover, it is a practice in which algorithms are equally visible to both the performer and the audience. Live coders, through this intimate relationship with their tools, offer a vision of what the cyborg musician could look like in an age of digital automation and reproduction, as realized through a few key practices such as open sourcing and human-computer dialogue. This creative paradigm stands in stark contrast to the music industry's relationship to algorithms at large. At present moment, the influence of black box technologies in popular music culture is simultaneously opaque and exploitable. Perhaps most notably within the context of creative development, Spotify offers artists the ability to understand themselves through the data the platform generates so as to appeal to a wider demographic. In a video titled "How to Read Your Data," Spotify executives note that data can help you see things you hadn't even thought about before. To demonstrate this, they feature a testimony from musical group Slender Bodies, who say that, through the Spotify data, we've come to realize that a lot of people consider us as electronic artists. It's surprising to see that considering how organic our sound is. Maybe there's a future for us doing some DJ sets on the side rather than just playing full live musician sets with a live band. Though they existed as musicians before Spotify, the data processing nudged Slender Bodies towards new behaviors and creative decisions in pursuit of further quantifiable audience engagement. There's a clear difference in Slender Bodies' use of algorithms compared to a live coder's use, which is that live coders' algorithms generate sound or visuals, while the other generates consumer data. What this example is meant to show, rather than the product of the algorithms, is the artist's relationship to algorithmic processes as a whole. The Spotify cyborg is blind to the large-scale processes which inevitably shape self-image, whereas the live-coded cyborg actively shapes the algorithms they use to reform their individual output. There's been another curious effect of widespread black box algorithm use. A new aesthetic has developed wherein human-produced artworks present as if they were algorithmically produced, or artificial intelligences. This cyborg, unlike the live coder, has their circuitry concealed in order to generate tension and confusion as to which parts of their construction and which are machine. Lil Miquela presents as a CGI-generated model with feminine features, dressed in high fashion and streetwear. Whether Miquela's actions are those of a robot or those of a human is unclear. The company behind her is made of human actors, however. Brud, the creator of Miquela, is a mysterious LA-based startup of engineers, storytellers, and dreamers who claim to specialize in artificial intelligence and robotics. Here, a black box conceals the efforts of human labor rather than those of an algorithm. That the creators of Michaela choose to present her as robotic standalone being shows that there is social capital at stake in the establishment of creative entities which authentically or not traffic in the aesthetics of consumption and algorithmic production. I'm going to fast forward a little bit here because I'm low on time. Even institutions have participated in Michaela's dissection. One video by New York Magazine walks through the processes of hijacking Lil Michaela in order to produce the digital figure in-house. The designer in the video superimposes an image of Lil Michaela over a featureless 3D model and subsequently distorts it over a generic model like a tight cloth. The practice of hijacking the cyborg is only possible because of the gates constructed by Michaela's creators. With more transparency in the creative process, one could construct a similar influencer avatar without the invasive practices demonstrated in the video. So here it becomes clear that black boxing algorithms don't prevent the replication and manipulation of artwork or even discourage it, but rather make it so that such abilities are only available to those with the time and resources to brute force a solution. Live coders also wield digital aesthetics for their projects, but do so in a way which makes the creative processes at play transparent. Live coding musician Mike Hodnick, aka Kindome, uploaded the repository of his RSIC chip release on Conditional Records when it was released in 2017. Through the GitHub repository alone, one could navigate to the software, samples, and code used for the project and theoretically recreate the entire album themselves from scratch. Hodnick even went as far as to include a README file and inline comments for each of the songs, as well as links to download for samples used in the project. It only took me a few minutes to boot up my copy of Title Cycles and paste in Hodnick's code to run it for myself. From there, I began fiddling with the numeric parameters for his functions, which in some cases noticeably changed the nature of the sound being produced and in other cases made no perceivable change. This moment presented an alternate vision of remix and sampling culture in which the source was not degraded or otherwise wrested from the hands of its originator. Walter Benjamin posits that to an ever-increasing degree, the work of art reproduced becomes the reproduction of a work designed for reproducibility. With RSIC chip as evidence, it seems as if open source albums are works of art designed not just for reproducibility, but also mutability. Without the inherent black box of an exported MP3 file in which all instrumentation, production, and human labor are condensed into a single file, RSIC chip explicitly eliminates the possibility of constructing what George E. Lewis refers to as a superperson. He states, "The better the machines played, and for my money, they do quite well now, the greater the threat to the mystery, and to an artist's strategic self-fashioning as one of a select band of designated super people with powers and abilities far beyond those of mere mortals." I'm going to fast forward a little bit here. Moreover, I'm now going to be talking about Brian Eno's construction of the musical gardener, which I think extends this relationship of the musical cyborg to something more organic. On generative music, Eno explains that one is carefully constructing seeds or finding seeds, carefully planting them and then letting them have their life, and that life isn't necessarily exactly what you'd envisaged for them. To compose by taking into account the output of the algorithm as something beyond the stringent will of the composer is to inhabit the mindset of the machine itself, and thus work not in servitude, but in service of it. Moreover, if the boundary between human and algorithm can be renegotiated through this process, perhaps so too can the relationship between algorithmic and seemingly non-algorithmic, non-human entities. In musician Koff Matthews' project Sonic Biking, the audience can cruise through landscapes on bicycles mounted with speakers. The audience moves through the sound, music, noise, and narratives that play, changing them depending on where they go. In finishing the project, Matthews came to the realization that there is no numerical data being read to create this music. However, the site, the moving street, I realize, is the algorithm, providing an invisible source that cannot be quantified or written down, but that utterly feeds and determines what and how things work and what therefore is made. Through her projects, Matthews has extended the coded cyborg to include the limited systems which process people and objects to perform specific tasks. Rather than limit the potentials of other objects by associating them with mechanic processors, this practice inevitably gives life to things which were thought to be lifeless, and thus allows the possibility of an output that is both mechanical and organic. To conclude here, the systems which govern current human relations are composed of the same unnatural, ideological code that govern copyright and creative relations. The cyborg is an ideal, and thus it can be an aspirational goal at every level of a stack, from government to culture. Perhaps we can recode the network from the bottom up and generate a system through small, deliberate changes over time. Building our networks towards the live coding cyborg brings us closer to building a protocol of trust between human and non-human, nature and machine, if such a boundary still exists. Thank you. I have some additional examples, and my source is listed in the paper, yeah. Any questions?
I can't see it, sorry. Oh.
Thanks for that. I look forward to reading the full paper as well. Yeah, interesting. So with Eno's gardening metaphor, it always strikes me that it doesn't seem very realistic. You don't just plant a seed and watch it grow. You have to do a lot of digging, and things never go according to plan. So is this a sort of critical view of Eno's idea that you're approaching here? Is it do you kind of subscribe to this idea of algorithmic music being relating to this idea of just planting something and then sitting back and?
Yeah, I mean, when I think of gardening in terms of the way Eno describes it, I think of some sort of more of a wild garden, like I guess in this picture here, where the plants sort of demand things of you. I think it's kind of like a mutual domestication. You're putting the plant into a garden, but the plant is also putting you into a cycle of watering it, planting it, taking care of it, like spraying it for mildew, as is the case with my succulent at home. But I think that in that sense, it becomes less of a controlling relationship between the two entities and more of like a, you help me with this, I'll help you with this. And so I kind of support Eno's current vision of that and think that fits well within sort of the live coding vision of sort of toning or helping the algorithm as much as the algorithm is helping you. Like sort of if it's sounding like your processor is like running too heavy and you need to like maybe take out some pieces so that your computer doesn't crash. I think that's a really interesting relationship to explore more.
First of all, really interesting presentation. I'm just a PhD student here, but it's interesting. I was literally just reading something before I came in, and you talked about kind of, I suppose, the deconstruction of barriers between the organic and potentially the technological. And I don't know, it's more of I suppose, a suggestion or a recommendation. I don't know if you've come across the work of Paul Sandin, who looks at the idea of virtuality in live music performance. And he speaks a lot about I suppose, the deconstruction of the mediated versus the unmediated. That idea of kind of breaking down those binary oppositions. He does an awful lot of case studies with regards. He looks at John Oswald's vein, for instance, and he looks at the concept of virtual liveness, where you're still taking that kind of traditional aesthetic definition of live, but you're also including you're including like the inclusion of technology and so on and so forth. So it might be something that you could look at if you are pursuing this further, because it really ties in and it's really interesting. It's really interesting work.
Oh, thank you. I appreciate it.
So much.
Can you tell me the name of that person again?
Paul Sandin.
Paul Sandin. Okay,
yeah.
Cool. Thank you.
All right, thank you very much. We have to leave it at this. We're running a bit late. Thank you, Jacob. All right, so off we go. Third talk is Sibo, right?
Sibo.
Oh,
yes.
Sibo, sorry. I'm reading it in the Italian way. Sibo version 2, real-time live coding AI agent. And the speaker is Jeremy Stewart.
Yes, sir. Let's see if this one looks okay. Cool. Okay. Well, I'm going to go straight to a couple video clips first. So I'll just leave this like this. My name is Jeremy Stewart. I'm here from Rensselaer Polytechnic Institute that's in Troy, New York. Sean Lawson is also here from RPI as well. And we had contributions from Mike Hodnick and Ben Gould on this paper, both of whom are independent. So this is a continuation of a project that was presented at last year's ICLC, which was a AI live coding agent based on a encoder-decoder neural network architecture, which was interesting and fun, but if anybody remembers it, it didn't work that well. It was still interesting, it just didn't work that well. It was not nice to try to train either. This is that agent, which was presented last year, just to give a little. Stuck in a couple patterns. This is Sibo v2, which is what I'm going to talk about today. So I'm going to talk about this, and also this software is going to be performing, I think, tomorrow night as part of the evening set, so you can see more of it there. Okay, so I'm going to walk through first, just really briefly, the pre-processing on this was sort of taking in this raw title code at the top, where each input into the system was one time that a performer hit Control-Enter to execute an entire block of code. So the length of each input sequence could be of any length. We tokenized this down, sort of putting aside integer values and string values and float values as a separate vector. So this middle vector here is just the tokenized form of the code input as integer tokens. And then through lots of finagling and fussing with it, realized that maybe just maybe these like single token values were kind of forming some sort of wall to better learning or better convergence during the system learning. So ended up combining up to 4 tokens into singular values here. This is sort of like the in-between translation step to get there. So really what we ended up with was our tokenized form could combine 1, 2, 3, or 4 tokens coming from the raw title code. The architecture on this is actually a bit simpler than the previous version, where we have some input vector at the top there, and we want to produce a new vector over and over and over again with this RNN, and then we want to decode this vector in the middle here, this normal distribution, decode that out into title code at the bottom. And in our case, there's 2 steps to the decoder. That's only important because it was trained in 2 stages. They were trained separately. So to sort of break down exactly how we trained this. This is the first stage, or no, this is the complete representation of the training process, where we have some tokenized input, and we actually want to get the same tokenized output. This is an autoencoder where we want to encode down to some latent representation that ideally is small and compact and adequately represents the code that then can be decoded out to usable tokens that can be converted into real title code. So importantly, this top bit could be of any length, and that inside bit we want to be maybe 3 values in the vector, or 12 or 24, or something much smaller and more usable. So first we train the outside 2, the first encoder and the last decoder. This is the chewy bit on the inside, which is in the paper, so I'm not going to go too deep into it. This portion is actually quite similar to the agent as it was presented last year, with a few differences. But basically we're reading in code, producing some latent representation here, where in this instance that latent representation might be 100 values large, or 200, or something larger than is ideal, or larger than the end product that we get to eventually. And then at the bottom here, we feed that into an RNN, and it just auto-regressively produces new tokens as output based on that hidden state. Here we're going to train these inner 2 second, and this is the variational autoencoder section, which is actually a pretty simple architecture that's just many layers going in, but importantly, the encoder models this latent state as a normal distribution that then we can sample as input into the decoder, and it actually has the effect of kind of making that latent state that we can look at the end and manipulate and play with is a bit smoother through the use of the normal distribution and the variational approach than a regular autoencoder might take. Okay, so putting it to use. This is the more hopefully interesting stuff. So this is back to the full architecture, the simplified view as it's trained. And for performance, we're just going to crack off this bottom part and use it, where we can input a vector into the top that's going to be of whatever the fixed size is, maybe 3 values. And it will decode out and produce title code that then we can convert back to, we can convert the tokens back to code. Yeah, less boring stuff. This is the interesting stuff. So in the course of this, we have this nice full architecture at this point, assuming we've trained it. We have this ability to represent something in a tight, compact way in the middle, using tokenized input and being able to reconstruct that input on the output. We can take this first half, which collectively is the encoder, ending with the latent representation, and collect all of those latent representations, where each one of those outputs will again be one time that a performer hits Control-Enter or executes a code block in Atom or whatever their editor is that they're recording on. We can collect these, and a sequence of these given an order would be a performance over 10 minutes, 5 minutes, 20 minutes, whatever. So from there, we can take those latent representations and visualize them. Here, this is a TS&E visualization of the latent space, which is sort of, TS&E is an algorithm that is really just for visualization, but it sort of helps clusters form. So we can look at it, and it's pretty but it's sort of a step away from the actual representation that's going on there. But we can also see, like, there's a little cluster off to the right. I'll explain. The left image is sort of like the head-on image, and the right image is sort of like rotate 90 degrees, so it's a side image within this three-dimensional space. And here, all of the red dots are code executions of myself. The green dots are all from Mike Hodnick, and the blue dots are all from Ben Gold. So my theory right now is this little cluster over on the far right on this image is actually all the instances where we're writing D1 silence or hush or some form of end sequence. And we haven't fully delved into exploring this space in terms of what is actually located at all of these locations, but I'm sort of supposing that my primitive title performing is probably the explanation for why all the red dots are right there. Most of my code input sequences are relatively short, whereas looking through the recordings that were provided from Hodnick and Gold, they were, much more developing much larger code blocks and much more complex functions within their performances. So back to here. We can collect all of these in order and then use that order to walk through some latent representation to hopefully produce a similar performance output. So that's what we did here. This is the actual latent representation of a three-dimensional latent space, where the line tracing here is actually a path that's walked through that within a given performance. And we can compare these and sort of see differences. Like maybe this is one where the recording ended before somebody hit silence or hush. Okay, so the very last little chunk here, because this is as far as we've gotten. If we decode this, we have this title string at the bottom here that still has stand-ins for integers and strings and floats, if they're there. We need to do something about those. So in the instance of Sibo 2, rather than trying to make one module that would handle it all, which is what we did for last year's model, we just constructed 3 different models. Each were responsible for a given variable type. And in the case of the string type, it would reference a dictionary that would, the output of the network here would serve as a lookup index for a dictionary to sub out on the final string. I think that's it, so I will take any questions or comments.
Thank you. I had a question. Can you give a little bit of the intro to this for people who did not see your talk last year? What is the overall goal of this project? Are you taking the title code and changing integer constants to something else or something like that? What's the goal?
The goal was sort of how to make a computer agent that could perform title either on its own or with a human performer.
So is it restructure the title code, or is it just, how does it keep from making a syntax error when it's rearranging the code, right?
Yeah, I'll back up here a little bit. So in this instance, here, it's actually being fed in raw title code that is integer representation of the code itself. Sorry? Yes. And then through the process of training this multi-stage neural network, it's actually able to generate those same sequences of tokens itself. It still makes some syntax errors, although with enough training, most of those syntax errors end up being similar to syntax errors that occurred on the training recordings themselves.
Okay. Thanks.
Yeah.
question that I have. So you're training on a corpus of performance data, basically.
Yes.
So what are your distance metrics, and what do they contain? Any perceptual distance, or really just the code edit distance, or what are you training on?
Right now, we've talked about how to incorporate some form of non-code feedback loop into the training, but that's still not here yet. So right now, it's training purely on code.
Okay. So from a perceptual standpoint, can you recognize the styles of the input performers, or?
A little bit here and there. I mean, I don't have a hard metric other than anecdote on that at this point.
Perfect, thanks.
Okay, just maybe it could help over lunch. I'm gonna share the papers. There will be though, like, as I underestimate the amount of work, so a month wasn't enough for me to create the entire proceeding in LaTeX. As you know, you submitted just a plain text. Now I'm going through LaTeX to do all this stuff. So I have all the proceedings except for figures and tables. I'm gonna share amongst the participants the final version of the paper, so you can see all the details. Maybe that could facilitate an understanding of especially this heavy technical talk. Is that all right for everyone? Yeah? Okay. Thank you very much.
Yeah, thank you.
Okay, so live coding from scratch, the case of practice in Mexico City and Barcelona. Presenter, Hernani Villanor. Welcome.
seems to be because you've got two different. You should be able to just mirror your thing in your display settings as well.
Hello, thank you for coming here. I'm Hernani, I come from Mexico. I will present the paper, Live Coding from Scratch, the cases of practice in Mexico City and Barcelona, in behalf of my partner, Ivan Paz, that he couldn't come today, but we work together to do this paper. So the contents of the presentation is an introduction to the paper, the experiences of live coding from scratch in Mexico City and Barcelona, some ideas around from scratch, and conclusions. So me and Ivan made this text collaborative based on our experiences as organizers and participants in the live coding communities of former Taller de Audio in Mexico City and Top Lab Barcelona. Live coding from scratch in this paper, we refer as a technique and a practice, and a series of performances starting from white screen against time, particularly 9 minutes from scratch, in sessions organized in Centro Multimedia and Barcelona, Hangar, in Mexico City from 2010 to 2014, and in Barcelona since 2018 until today. So, live coding scene in Mexico City began in a public space called Taller de Audio del Centro Multimedia. We can mention some artistic and education events as antecedents of live coding from scratch performances in both places. As artistic antecedents, we can mention the audiovisual trio MU, formed by Ernesto Romero, Ezequiel Netri, and Eduardo Melendez, as the first band to live code around 2006, as you can see in wiki of Top Lab. And then maybe the first solo of live coding called Prácticas con Código Vivo by Ezequiel Netri. This was maybe the first live coding concert that someone in Mexico showed the code in the screen, as the concert we know of live coding. That was in 2009. As an education antecedents, we can mention the series of Super Collider workshops run since 2007 until 2040, and another workshops as processing, pure data, open frameworks, and Fluxus. This workshop was taught with a strong flows discourse from 2007 to 2010. So in 2010, there were many alumni that have a creative coding background. So we in Taller de Audio thought, how can we invite these former students to present their works live, not only to attend workshops, but to present in public. So we planned some concerts and live coding sessions. But it is until 2010, after a workshop taught by Luis N. del Ángel, a Fluxus workshop, that the first live coding session was possible. So for that occasion, former students of Super Colliders joined the concert and figured out how to live code in Super Collider. And students that just have made the Fluxus workshop live code image that was in December 2010. And after that, a series of live coding sessions from scratch around 2011 to 2014 were made. Around 30 live coding from scratch sessions in different places, not using Centro Multimedia, and 3 symposiums called Sibo of music and code. One of those was dedicated to live coding in 2012. So at the beginning of those sessions in 2010, there was not a clear definition of what live coding is. So the references were the Top Lab web page, the GitLib part of Super Collider, and Fluxus. Live coding was a synonymous of from scratch. That is to consider a performance live coding, it had to begin from scratch. So with this in mind, a first definition appears in the web page of Centro Multimedia, announcing one of the live coding from scratch sessions. So this consider live coding as a sound programming practice in the domain of music and sound improvisation with an extension to visual. Later, a second definition consider live coding, both sound and visual, as a programming practice with their own aesthetics discourses. In these live coding from scratch sessions, usually a pair of live coders were presented from an open call, one programming audio, another programming visuals. And we have 9 minutes for each pair of live coders. So we made rules for these presentations. The first rules were write code from scratch in order to generate sound or image in the preferred language, but mainly was Super Collider and Fluxus. In 9 minutes, and when the audience applauds, stop. In 2014, there was the last live coding from scratch session in Centro Multimedia in Mexico. And 8 years later, in Barcelona, the collective live coding Top Lab Barcelona that is in residence in Hangar Center start to organize monthly live coding events such as algo raves, live coding concerts, and live coding from scratch sessions. From scratch was not well-known technique in Barcelona, where in this In Barcelona, performances were with prepared system and pre-grading code with different languages. From scratch sessions began with the same rules as in Mexico City to emphasize writing code in real time. That is because Ivan Paz, one of the members of Top Lab Barcelona, was in Mexico organizing and participating in these first live coding sessions from scratch. So he imports the model to Barcelona and start to organize also these live coding from scratch sessions in 9 minutes. The difference with Mexico is that in Mexico, we consider live coding from scratch a practice. In Barcelona, they consider mainly as a technique. So another difference is that from the first presentation, they use many languages, not just Fluxus and SuperCollider, but many, many languages. So one question arose in how tools and abstraction level impact the sonority. Mainly they are focused on making sound, even they also promote visual live coding. So in 2019, members of both Sense have an encounter during the first BU festival organized in Hangar Center by Top Lab Barcelona. That was nice to have both members of both Sense together making 2 from scratch live coding sessions in 9 minutes. So Top Lab Barcelona definition assumes from scratch as a technique, as I mentioned, that allow to see the level of the programming language and that make transparent the live coders tools. These definitions have a musical approach to live coding. Even Top Lab Barcelona promotes also visual live coding. This definition remarks the restriction of 9 minutes as a creative possibility. The rules are mainly the same, but they include rules for the public, for the audience. So they remark the gathering of audience and live coding coders in these sessions. They ask the audience to applaud at the end of the 9 minutes, but they remark this is just for fun. For live coders, there are only 2 rules. Start from a blank screen, and you have 9 minutes. Some ideas beyond from scratch is that live coders demonstrate coding skills and give an insight of their minds. Their error is part of the performance and is welcome. From scratch can be understood as an exploration tool that allows to find first possibilities of a language and glimpse different possible paths. The time constraints and blank screen approach show the abstraction level and design of a language. Using vanilla versions guarantee that code can be studied by anyone, of course, who understands some language. So you can recreate maybe some performance or just to see how it is made, what strategies the live coder use. Also, the public try to understand what's happened in these presentations, but a clear and simple explanation are required before. Another idea is that training AI models on the fly remain from scratch performances. That is, after some presentations in Mimic projects in Brighton, I think, that Ivan saw maybe Mario Balmand training live some models, so it reminds a little bit from scratch performance. So some conclusions. From scratch technique emphasizes real-time code writing. The Barcelona polyglot approach allows to see the abstraction levels and designs of the program. This has provoked questions regarding the impact of the language in their artistic output. In Mexico, the homogeneity approach, that is to say, using Fluxus and Supercollider mainly, allowed to share and learn from others, generating, as Carolina Di Prospero called, sociability. In both cases, we can say that this approach points out the definition of a practice and the construction of community through a technique. Thank you. So if you have questions.
You've used this term from scratch quite a lot. I'm wondering how much you thought about or had dialogue about where the line is between the empty screen, the on-scratch environment, and all the ecosystems and contexts and abstractions supporting that. Given that nothing's really from scratch, did you have any discussion about where you started from and what you called the empty environment?
Yes. Well, of course, languages and software have many black boxes. As when you open Supercollider with a white screen, of course, there is the uTLIF constructed behind. Little by little, we start to reflect about these black boxes. Personally, I start to research about how, as an artist of live coding, open these black boxes. So that's why the concept of programming levels are here. So in Mexico, we understand first that this is open a white screen is like begin from nothing, but this is not true, but because, as I mentioned, there are many black boxes. But in Barcelona, they have a range of abstraction levels. They use very high-level tools and very low-level tools. Sometimes I remember some performance, maybe by Nicholas Reppel, that use C language and try to construct some in the very bottom. But at the end, there are a lot of boxes and boxes and boxes, black boxes. Yeah, for us, white screens is just using a vanilla version, opening the software, and what we saw as a white screen, that is the limit of making live coding from scratch with the conscience that there are many black boxes behind. Yeah.
I just have a really short question. How did you get to 9 minutes as the duration for the from scratch?
Okay, that was a process. Actually, the first presentation between former students of Supercollider and students of Fluxus, we have 15 minutes. For beginners, there was many, all the students, there was the first time they figure out how to do live coding from scratch. So 15 minutes was a huge time this occasion, so we realized now there is so much for a beginner, even for the teachers that have some experience. 15 minutes was kind of a huge time, also for the audience, because seeing someone programming a SynDef maybe in 10 minutes, nothing sounding, and then after 10 minutes, a blip comes. That was 15 minutes. It's a long time. So we reduced to 10 minutes. And then was also kind of pretty strict number. And we say, why not 9? And was perfect. The first session with 9 minutes was perfect because the beginners have enough time to arrive to some points, maybe in 3 times, because we rehearse a lot before this concert. We don't arrive from scratch. We have a process in houses and studios, like practicing, maybe reading some in a, we have some shit, transcribing. We use many strategies, but after some sessions, we found 9 minutes was perfect for beginners to develop this sonic and visual discourse. And then after 5 sessions, we decide 9 minutes, it's okay, and then all is history. We have a lot of successful with these sessions, and also we can include as many as possible of live coders in each sessions, like 1 hour and a half concerts. That is a lot of time for a concert, but we have also this possibility to include as many as possible live coders. Have sometimes that the live coder is comfortable to develop something, and yeah, prove an error was the.
All right, very short question. We are running out of time.
First of all, thank you, Hernani, for the conversation. I think it's very interesting to approach live coding not only as a technical or technological problem, but also a social one. And I like the approach of the cultural consequences of live coding and collective ideas of live coding rather than this almost one-to-one relationship with the computer and one person programming, no? So thanks for that. Also, I would like you to elaborate a little bit further about the pedagogical implications of from scratch live codings and what those mistakes and errors mean in these kind of practices. Maybe you approach this a little bit, maybe you can elaborate a little bit further.
Yeah, of course, this have an educational background. We just put students like push. No, it's easy. You should try. And then maybe students were a little bit scared. But yes, this practice, practicing and practicing in house and in front of the public, little by little, a lot of live coders start to be more comfortable and develop careers, international careers. There are many of you that are sitting here that start in these sessions. There are many others touring the world. But yeah, the origin was an educational effort to just do it. Yeah, there was a previous training, but it has an educational intention. Yeah, of course. Well, thank you.
Right. There was one last question there. Maybe the next speakers can prepare in the meantime.
They have lost experimentation, they don't do new things, so what do you think about the community in Mexico right now and not doing this anymore?
Yeah, that was a shame because after 2040 there was many of us quit Centro Multimedia and start our own careers in academia. Many of us start PhDs or master degrees. In that moment, yeah, there are many live coders, mainly making solo activities. There is not more maybe like a community sense. There is more a scene of live coding in Mexico. There are many famous live coders touring, but as an isolated cases, that is a shame because we have not anymore the space, the energy, maybe we are not joining each other's again. I made some intent to do some things in my university in UNAM, in the Faculty of Music, but this first explosions lost, shamefully. But it's like that. It's like each one takes their own ways, and I'm very happy that in Barcelona, Ivan is taking this kind of projects. I hope that little by little, after a pause of 6 years, maybe we can still retake these sessions, because many of us are in a process of making PhDs, but I think when we finish, we have now taken care of some spaces, and maybe we can push again this initial explosion of live coding. But yeah, now there are many live coding, but not in community, more isolated cases.
Thank you very much, Hernani. All right, so designing for a pluralist and user-friendly live code language ecosystem with Sema. Presenter, Francisco Bernard, Chris Kiefer, and Tor Magson.
All right, hello everyone. It's great to be here, see all these great projects and fantastic keynote earlier. We're gonna talk about a system that we're working on called Sema. It's a live coding system for designing your own live coding language. But it's part of a project that we're running between Goldsmiths and Durham and the University of Sussex, where we are based. And the project is about getting machine learning into the hands of artists, into the hands of creative coders. So we're simplifying the whole machine learning tool chain and giving people tools that are easy to use. And we use JavaScript for that. So whilst Goldsmiths is thinking a lot about machine learning and the whole framework of the system, up in Durham they're looking at machine listening. And in Sussex we are thinking about how we might create a good user interaction framework to engage with or interact with machine listening and machine learning. And of course, live coding is one such way of interacting with machine listening. So our project is to come up with a live coding language for machine learning. And then we thought, why do we need another live coding language? It was a challenging question at the Web Audio conference in Trondheim just before Christmas. We were talking about this. Is it really necessary? And so we started to think, what kind of language would we come up with? You know, do we want a high-level language, low-level language? Is it going to be object-oriented, functional? What is it really that people want? So we did some user studies, and we asked people how they thought they would want to work with machine listening and machine learning in a live coding language. And it was very clear that people wanted hybrid approaches and multi-paradigm languages. So people wanted to be able to use object-oriented architectures when needed, but a lot of people preferred functional programming. And then it was all this talk about being flexible and expressive, high-level languages that can extend and good for prototyping. People wanted good quality documentation and examples, and of course a clear and informative error system. So this is what our goals are really, to come up with something that supports these hybrid approaches. And in a nutshell, so brevity, simplicity, expressivity, flexibility, adaptability, and plurality in design. So how do we come up with something like this? And that's really what our project is about. We designed a language or a system called Sema, which allows you to create your own live coding language. interacting with a sound engine that is written in C++ and transpose that to transcompile that to JavaScript. So why would you want to create your own language? And our idea is that if we only have a few live coding languages, people start to think in very similar ways. They start to make music that is maybe sounding a bit similar to other people's music because, of course, the language controls the way you think. So our idea is or hope is that people are able to come up quickly with their own languages, because our system is relatively simple, quickly come up with their own languages for their own little ideas, whether it's a piece, whether it's an instrument, whether it's a kind of part of an ensemble. The people come up with their own languages for particular purposes. So instead of, many of us, we have created languages and it's taken us months, if not years, to come up with a language. But in this case, we're thinking, oh, you make a language in an evening, you know. It's that simple, and the framework is made for that kind of way of working. So many languages, plurality of languages, one language for breakbeat rhythms, another language for bass, So this is the idea that we have. So I'm going to hand over to Francisco, who's going to explain a little bit more.
So I'm going to present the response and the solution to this question that we've engaged in a design exploration of how to provide the community with a system that can actually enable them to design multiple languages. And this is Sema, a live coding language design playground, which is available on GitHub. I'm going to make just a small demo. So this is Sema on a different resolution than usual. I can just scale up and let it be sound. Thanks. So what we have here is a different assortment of panels, some of which enable you to code a live coding language, some of which enable you to design the grammar of the language, such as this one, for instance. So this one is where you define the rules and the tokens of a language. And it's a process which is reactive. You can prototype your language in real time and come up with a language that is structured with tokens or Bacchus-Nauer syntax. And you can also then, this process generates a parser in real time, which will then compile in real time a language that is defined by that grammar. So for instance, if I want to change this language, which uses a specific character like brackets as delimiters, so right now, the compiler is saying that we have an error. So if we just replace, then we have a new language. And there's also a bit of machine learning integrated, which is on this bottom panel, where you can instantiate in real-time TensorFlow JavaScript. And you can, for instance, tweak and structure a neural network architecture and train it in real time. So we don't have, so I can show, let me see if this is visible. So if I evaluate this model, I just triggered a training process with these parameters, specific number of epochs, the history of the calibration of the error. So, now I have the eval command in my muscle memory. So as you've seen, we have these regions. We've also have a tutorial section that I didn't show, but that we'll be using on the workshop today. This is the workflow in Sema with the main user entry points. The user interacts with the grammar and interacts with the live coding language, and then can engage in this design exploration by defining the rules, tweaking the language, and the internal workflow work process that goes under the hood Sema is a parser that generates an abstract syntax tree that then generates DSP code, which is written in JavaScript for a library called Maximilian, which we built our audio engine on. So Sema in reality is a reactive compiler, a real-time compiler that runs on the browser. And the user language that you design and use to perform gets compiled to this almost not gibberish, but this is the real code that's running in the audio engine thread. And to motivate a really effective, to support an effective performance, live coding performance, we had to design a special audio engine that runs on its own audio thread. So we're using audio worklets, and that was the subject of our previous paper at the Web Audio Conference. And it's a multi-worker architecture in which we try to separate machine learning processes, machine listening processes, and audio rendering from the UI thread. So there were some issues with the script processor node, which is one of the old implementations in web audio. And basically, to tackle those issues, we implemented a new audio worklet solution. So now we're going to focus on some of the design principles that we've started with Sema, and I'm passing to Chris.
So yeah, I'll just talk a bit about the kind of lower level design principles we had with the audio engine. This audio engine is it's in audio worklets, as you've seen already. So when we're coming to design a new engine, we thought about these things, that we'd want to do a single sample audio engine in the way that we're trying to think about. We're not trying to prioritize efficiency of having things like control rate and audio rate. We're just going to keep it simple. It might cost some efficiency, but we want to keep it simple to make it more usable, I guess. We have this thing, we call it the signal engine rather than the audio engine, because we want to be fairly agnostic about what we're processing in that audio engine, in that we want to be able to process things like sensor signals or video data. So our concept is to have an abstraction called transducers, which converts incoming data into audio format and then out again on the other side. So everything gets processed within kind of audio concepts in the audio engine, but might come in and out in different dimensions and rates. And we try and minimize the abstractions in that this toolkit our system is a kind of meta toolkit, you might say, for building other languages. So we didn't want to impose too many abstractions on the user, as little as possible. So you won't find a synth in our system. You have to build the synth yourself, and that kind of goes together with making your own language. We don't know what people are going to do with it, so we've put kind of very granular building blocks that people can combine into their own purposes. So this is the general workflow. So we're really focusing on the machine learning side at the moment. We've been building up the language design, and we're kind of trying to integrate the machine learning research from our research partners at Goldsmiths. We did some load testing on this. I won't go into too much detail about it, but because we're using audio worklets, there's some kind of questions around efficiency, latency and what you can actually do with a new audio engine in this format. And so we developed a system. This is a really, really simple language. It just does trees of sine oscillators. How many sine oscillators can it run is usually a kind of very crude measurement of how well an audio engine is doing. Of course, it's more complex than that. But we kind of randomly generated code in this language and threw lots of these little bits of code at the audio engine for about 10 hours and evaluated its average response. The general message was that in kind of latency terms, things tended to between hitting go and actually hearing something usually happened under 20 milliseconds, so it was sub-perceptible, which we thought was appropriate for live coding. And in terms of load testing, on a fairly old laptop, 4 years old, you can get about 250 sine oscillators at once out of it, which is probably good enough for a lot of applications. Of course, not some of the more complex synthesis methods. So there are some limitations there compared to something like SuperCollider. And that's probably due to JavaScript running a bit slowly and the really low latencies that audio worklets, buffer sizes that audio worklets force you into. I'm going to hand back to Sam.
This year in July, we did a summer workshop with some of you that are here. We recruited some users to test our first implementation of Sema. And we've invited people from different countries in Europe. We had a selection process. We had these sessions, induction sessions in language design, induction sessions in machine learning, some presentations of a design studio counterpoint that works with Google Magenta. Shelley did a workshop in machine listening. We had Marai and Enrique, which were invited artists that were developing or augmenting some of their instruments with Sema. And we also invited participants to design their own languages or to engage in the process to come up with a language or to use Sema. And by the end of the workshop, 3 of the participants were able to either design their own language or customize Sema with audio visuals or with some strange combinatorics in the process. And this was all fitted together in a nice event that took place as the Mute Lab 4 in the Rose Hill pub. Some of the key results that we have observed on that study were that there were 2 new user design languages. There was customization of Sema, downloading a fork of the solution and appropriating it for their own idiosyncratic uses, and some extensions to the default intermediate language. And some of the conclusions that we obtained were people enjoyed the quality and the reliability of the audio engine, but they asked for more flexibility and transparency, to integrate grammar design and parser compilation in the whole workflow, which wasn't, as you've seen now, it was a different process, and to clarify entry points between novice and more expert users, and to explore design abstractions for the languages and for the general parameters. So that's it. I think there's something else that we want to say about the user participants. So basically, we're going to launch Sema in the first version in end of March, and we will be inviting people to participate as users to improve the general usability of the study. So whoever wants to explore this more seriously and work more closely with us is definitely welcome. So, thank you.
Right?
Hello, thanks for this presentation. This is a very cool system. I was wondering if you're thinking about, or you already have some way to represent, like some kind of support for a way to represent time that could be useful for kind of synchronizing things happening from the point of view of the execution of the language and the signal, the samples in the audio engine.
I mean, I think time is definitely something to worry about. It's essential. But it fits on that, I think it fits on that general response that we have, that any general abstraction over any specific language or audio aspect should be designed by the user himself. And we're providing the medium and the ecosystem and the tools that support that. But in the future, we'll probably come up with some specific components that will fit in the environment, in the playground, and that will help the perception of audio, for instance, but we're moving that to the user design space rather than the platform developers design space, if that makes sense.
Sure, yeah, I was just imagining that the engine itself may need some sort of hook to do that. But of course, it would be very useful, I think.
Some sort of hook.
Yeah. If you have to synchronize to the sample level, I guess some
right.
support from the platform.
Yeah, there will be support from the middleware, of course. But like for instance, visual representations of time will have to get that hook, and but that's a really good idea to provide. Yeah.
Yeah, the transducer system that Chris talked about allows us to take anything from the audio and visualize it, for example, at a different rate. Mm.
I had a question. How is the machine learning stuff integrated with the programming language part? Is it a separate panel where you can play around with ML, or is it somehow integrated with the language code?
Well, at this point, it's separated into a different panel, but the idea is to make it part of the user-defined language. So as we provide like components, or modular components for the language design to interact with the audio engine, we want to do the same with the machine learning part and provide it as a whole, like a whole interface that the user can actually make it part of the grammar design rather than just, because by now it's just like communicating with a channel, like streams being exchanged between one panel and the other, or something under the hood. But the idea is to integrate everything.
Thank you.
Oh,
Hello. So you said it's about I can't say it. You know the word I'm trying to say. But what about universality? How easy is it to implement existing languages like tidal or extempore in Sema?
Right. So that's a great question. Well, these are the early days of the platform, and the difficulty of that universality entails, it's directly related to the complexity of our compiler. So for now, our compiler enables users to design like simple functional languages. You can't use classes, for instance, because our compiler doesn't have the complexity needed to, make to do the code to do the parsing and the analysis and the code generation that it entails. For instance, scopes, classes, objects. So for now, we have a very simple functional language, but the idea is in the future to scale up that complexity of the compiler and provide support for more complex languages, and ideally for all languages that have been implemented. All in our favorite browser.
The question is, who's going to do all that work?
Yeah, that's right. Or who's going to fund that work?
All right, lads. Thank you very much. All right, now 2 minutes of patience. The last speaker is going to join us remotely, so I have to set up here. Fingers crossed it's going to work.
Hi. Woo. Oh, can you see me okay? Oh, I've lost you. Okay. So I'm just going to read my paper because it seems like the easiest thing to do. Except my computer's now doing weird things at me. Okay, here we go. The project takes a universal design approach to exploring the possibility of creating a software platform to facilitate a networked ensemble for disabled musicians. In accordance with the Nothing About Us Without Us principle, I worked with a group of 15 professional musicians who are also disabled. The group gave interviews as to their perspectives and needs around network music practices, and this data was then analysed to look at how live coding software could be developed to make it more accessible. We also identified key messages for the wider design of digital music instrument makers, live coders, and performers to improve practice around working with and for disabled musicians. Definition of terms. In this paper, I will use the terms disabled and non-disabled in line with the social model of describing disability. The social model of disability describes how disabled people are not disabled by our bodies, but by a society which creates environments in which we cannot function. This is the process of society and structures actively disabling people. For example, the person who uses a wheelchair is disabled by a decision not to include lifts and ramps to a building. It is the design of the environment which disables them. Following this theory, a person with a fatigue condition is disabled from taking part in a project because of the long days scheduled or the distance travelled. The design of the project has disabled the person. A non-disabled person is one for whom the structure and design of society broadly works. I will also use the term D-Deaf, which is a term which refers to two differing communities and political positions on deafness. Small d refers to those who have partial hearing or use spoken language as their first language, and capital D-Deaf refers to those who use sign language and consider themselves culturally deaf, that is, to live in a more visually orientated culture outside of spoken language. I use the term disabled musicians to mean disabled people who have a professional or semi-professional music practice, as distinct to using music as a therapeutic or community building practice with disabled people. It may be that some of our findings may be suitable and transferable to the therapeutic and community music research environment, but that is not our focus. Why we did it: dreams and possibilities, and manifesto. We would like to see action from the live coding community to listen to the needs and concerns of disabled musicians around the making of live coding musics and platforms. We would like to see ensembles, rehearsals, conferences and performances which respond to the requirements of disabled people. We would also like to see the community provide learning opportunities for disabled musicians to learn live coding and software development. And we would like to see disabled access built into the core of music technology software. Disabled access and universal design. Why disabled people must be at the heart of developing technology. The extension of the social model approach is the Nothing About Us Without Us concept, which holds that for those for whom a service, system or environment is designed, must have a contributing say as to its design. By incorporating diverse voices into the design of something, we can more reasonably design something which fits those it will serve. The work is extrapolated by Jutta Trevinarius in her work on universal design. The first principle of universal design is equitable use and is broken down into the following 4 categories. 1. Provide the same means of use for all users, identical whenever possible, equivalent when not. 2. Avoid segregating or stigmatizing any users. 3. Provisions for privacy, security and safety should be equally available to all users. And 4. Make the design appealing to all users. The next logical step to universal design is the concept that everything that is made should be made by a wide range of people for the full range of people. In this way, we can ensure that we turn made for into made by. By incorporating this into our design, we can avoid cultural appropriation, perpetuating stereotypes, assumptions, supremacist perspectives, and oppression. For example, a recent development of gloves which interpret sign language into spoken text has met with negative reaction from some D-Deaf communities. Academics from the DDEF community roundly criticised the gloves, which claim to turn sign language into spoken language for a number of reasons. Firstly, that the gloves only interpreted alphabetic spelling, which is a tiny part of sign language. Secondly, that the hand and finger movements are just a small part of signing, which uses facial movements, mouth movements, and eye movements as part of the language. Thirdly, philosophically, the gloves reinforce the notion that DDEF people's communication is a thing which needs to be solved for non-signers and puts the responsibility for that back onto the signer, to buy, to train, and to use the gloves for the benefit of the non-signer. This was seen as cultural appropriation and a colonialist approach to technology and disability. If DDEF people had been included in the conceptualization of the project, and if the makers had read and understood disability culture and politics, this could have been averted, and something more useful and equitable could have been created. From a development point of view, then, it is vital that approaches to disabled technology come from the community with an equitable approach, rather than to fix a problem perceived by the non-disabled community. It is this co-design which we can import to music technology, and specifically live coding, in order to make it more flexible, robust, and inclusive. Why live coding? In this paper, we specifically focus on live coding as a way of exploring disabled network performance, building on a recent strand of live coding research that considers diversity from various angles. By making this work about live coding, we have the opportunity to design things from scratch. Coding is design. When we code something, we make it new from scratch, and we can make it to suit ourselves. This allows us multiple levels of engagement with the universal design movement, which can support disabled people in making their own technology and having access to skills to adapt it as they see fit. This shift in power from the made for to the made to the maker means that disabled coders can be at the forefront of countering potentially unintentional ableist music making. There are also a number of key connections between the concerns of live coding research and those of disabled studies. Firstly, a focus on open source software potentially responds to a major concern for disabled artists: the cost of software purchase, maintenance, and deployment to diverse computer platforms. Secondly, live coding can often be accomplished without a requirement for specific hardware, such as MIDI control surfaces, whose buttons, faders, and pots can cause difficulty for disabled people with motor control issues or upper limb difference. Thirdly, and conversely, live coding's enthusiastic embrace of alternative and diverse programming interfaces connects readily with the use of additional hardware such as eye gaze and head mouse controllers that might be required for people with particular needs. Fourthly, live coding often takes the form of network performances using a shared media surface. Moreover, when such network systems transmit code rather than sound, bandwidth requirements are reduced substantially, making them useful to home-based disabled artists, for whom the majority of their work may then be performed over the network. Finally, the work of the live coding community in breaking down expectations about performance and audience, for example, watching someone code is a relatively new progression in terms of gig experience, can create an opportunity for us to rethink how performance can be made more disabled friendly. Networks and online presence continue to be a powerful and revolutionary tool for the disabled community. There are obviously important concerns around surveillance, facial recognition, technology, racist algorithms, and oppressive regimes. However, on a very simple level, disabled people with limited mobility or with limited income are able to meet, support each other, and undertake activism online. We are still subject to those oppressive technologies, of course, alongside trolling, hate speech, and unfair representations in social and traditional media. But we are liberated from bodies and minds which do not easily meet and communicate in person. In this way, networked activity offers a means of collaborating specifically useful to home-based disabled people. In this case, the question of the impact of networks can come down to ownership, authorship, and agency. Whose algorithms are these? Who do they represent and fail to represent? How do users have control over changing how something works, understanding how their data is worked, and governing its use and aggregation? So again, by shifting made for to made by, we have the opportunity to address power imbalances, structural oppressions, and bias. What we did. In order to reflect the principles of universal design and ensuring that the users had as much influence on the process as possible, we interviewed disabled musicians to find out their requirements and then attempted to design systems according to our findings. I began by contacting home-based disabled musicians worldwide using social media. I conducted 15 online interviews with home-based disabled musicians to explore their approach to music making, their requirements from a music making applications, how should it be laid out, what platform works best, what controller adaptations may be useful, etc. The requirements for learning and workshopping ideas, how long can they concentrate for, how long can they control the software for, how best to communicate during the workshops, and their requirements for performance. Can they do real-time performances consistently? Would they need to pre-record aspects of the work? How long can they perform for, etc.? The interview process was granted ethical agreement by the University of Plymouth Arts and Humanities Research Ethics Committee, and all data is held in compliance with GDPR, the UK's Data Protection Act 2018. The interviewees. The interviewees represented a wide range of disabled musicians and also included 2 non-disabled academics who work in the fields of adaptive music technology and live coding. Although one of these has lived experience of being disabled, they do not currently identify as disabled. The group of disabled musicians included a range of backgrounds and experiences, from acoustic performers who had limited experience of working with music technology to those who have performed as live coders. The interviewees also represented a range of impairments, racial identities, genders, and sexualities. This was explicitly chosen as a strategy as to not foreground a white male perspective. As the pool of disabled musicians who are interested in network performances is a particularly small group of people, we were unable to be as diverse as we had hoped. However, our group was reasonably mixed. Disabled identities included limb difference, mobility issues, hypermobility, stroke, recovery, DDEF, ME, diabetes, schizophrenia, autism, and ADHD. 2 interviews identified as Black British, 2 as British Asian, and the rest as white. 9 interviewees were male and 6 female. Findings. Findings from the interview show a wide range of preferences, requirements, and adaptations. Those requirements broadly fell into 4 categories. 1, physical adaptations, 2, communication preferences, 3, fatigue requirements, 4, social interaction. We mention this because physical adaptations and communication preferences are often foregrounded in disabled access projects, while fatigue requirements and ways of structuring activities and social interaction are less commonly considered. The paragraphs below show the different responses to the questions which were put to the interviewees. Hardware. There was a roughly even spread between those who favoured the use of a computer and those who preferred to use the tablet or phone, with some saying they would often switch between the 2. Preferences for using a computer included larger screen size being easier to view, the keypad being easier to control than a touchscreen, and there is more control over connecting different applications, and that it is easier to plug in adaptive hardware such as eye gaze or head mouse. Preferences for tablets and phones included being easier and lighter to transport, that the touchscreen is less impactful on hands and wrists, that the touchscreen allows interaction for those with less motor control, and that they are generally cheaper to purchase than a computer. Design and display. The majority of interviewees requested that an electronic music environment's colour scheme and display be fully customisable, with users able to choose their own background colour, font type, size, and colour. In addition to this, interviewees requested that the different elements of a user interface or display are placed in separate windows which can be moved around the screen, resized, zoomed in, or out. This reflects a network community perspective where each individual is able to define the circumstances in which they work best. By providing customizable display and design, we give each person, and not just disabled people, the ability to create their own workspace. One of the interviewees controls his computer with a head mouse, using his tongue to move the cursor and blowing into a tube to click. The head mouse has no double click or right click function, and in order to control click, he has to request his assistant to hold down the control button. For this user, it's important that there are no double click or right click actions. In order to type, he has to select a screen alphabet and click on each letter, which is a slow, laborious process. Barriers to engaging with new music making software. One of the key barriers to engaging with music technology was cost, a place where open source live coding community has already made significant inroads. There were also concerns around whether using computer coding to make music is a real music activity and whether it would be seen as such in the community. Another barrier was the time it would take to learn a new approach to music making. Many disabled people have pain and fatigue conditions, which means that they have less time to function on a daily basis. They may only be able to concentrate or cope with a display screen or controllers for 10 to 20 minutes a day. This means that it's important that results can be heard after a relatively low amount of time working with the software. In addition to this requirement, 2 of the interviewees told me that disabled music technology applications tend to have a limited progression, which does not allow for continued growth and learning. So although the research shows that disabled musicians would like to see fast results, they would also like there to be an opportunity to grow within the software and increase complexity as they learn. Some of the musicians raised the issue of unnecessary technology being made for the disabled community without their consultation, as discussed above with the sign language gloves. A further barrier was around the issue of updating and fixing problems. Much software is made specifically just for disabled people by individual developers and university departments. However, there is limited budget and time frame for these projects once the software is built. This then leads to issues when the software is no longer compatible with the latest updates, or the disabled person has accidentally changed a setting that requires in-depth knowledge to fix. This issue of bespoke software requires bespoke support, which is rarely available. Therefore, there is a preference for standardizing software to be made disabled friendly so that it is regularly updated along with the mainstream aspects of the program. Another barrier was the perceived difficulty of learning to code computer music and a gap in the knowledge around what live coding is. In some cases, it was considered as an activity where musicians would have to start from scratch, and it was only suited to programmers or coders. Preferred methods of learning new software. Methods showed a diversity of preferences, with the majority wanting to learn by trial and error, with help files to refer to as support. The quality and accessibility of help files was brought up by at least half of the interviewees as an issue for learning new software. Our interviewees told us that help files must be written in clear language, in an accessible font, and be consistent throughout the program. A small minority preferred to use video tutorials, but with the stipulation that these should be scripted, structured, captured, and given tags to enable the user to skip through to the section they require. Video tutorials should show the actions at the same time as the explanation, along with clear captioning. The view of the screen grab must be clear and legible. Interestingly, those who preferred video tutorials were also the people who had the most experience of working with music technology and live coding. It is possible that this correlation shows that video tutorials are currently more accessible for those with background knowledge and/or confidence in the field, although more research would be necessary, as this is a very small sample. Only one person said that they would prefer to have someone help them on a one-to-one basis, with 2 expressing that this would be their absolute last resort due to social anxiety or communication barriers. 3 said that they would find an online workshop situation difficult due to social anxiety, attention span, or communication issues. Accessing forums for support was also considered to be challenging for reasons of social anxiety, for fear of being dismissed or undermined or asking stupid questions. It was also raised that often the responses received in forums can be either incorrect or overly complex, leading to frustration. Finally, there were comments about how forum environments can often be challenging for those for whom social interaction is difficult and can lead to arguments or flaming due to confusion over the tone of a comment. What would a disabled-friendly gig look like? The response to this question showed a range of requirements and preferences amongst the group. In a live environment where the performer was present, and most welcomed a quiet or silent space where they could relax before, during, and after the gig. It was also mentioned that many chill-out rooms tend to become colonized by groups, and the focus changes from quiet space to alternative music or a VIP space. One of the musicians said a private space for people to go to if they needed space and quiet would be good for the general audience too. There were also requests. There were also requests for healthy diet, appropriate food and drinks for those who have allergies and intolerances, and sugary food and drinks for those with diabetes. A flexible approach to programming the running order was also considered desirable, with musicians having the ability to rearrange their performance order or slightly adjust times based on how they were feeling. One of the musicians said they needed a clear structure and knowledge of what would happen in each section and how long each section would be. What issues are there around performing live in a networked ensemble? Many of the performers cited a lack of eye contact and physical communication between players to be a major concern in playing in networked ensembles. Others were concerned about latency. Concerns about latency were expressed in terms of hearing back the ensemble playing out of sync with your own playing. Implementing findings. These responses lead to two specific channels of development. Firstly, what changes could we make to live coding software which would support disabled people in becoming part of the community? And secondly, how might we change our working practices to accommodate disabled people in ensembles and performances? Software design messages. 1. The need for complete flexibility of layout, design, and display, allowing people to create a workspace which works for them. 2, the need for software to deliver musical results quickly, but also allow for ongoing progression and development of skills and complexity. 3, the need for well-documented, plain language accessible help files. 4, the need for captioning and scanning through video tutorials. 5, the need for software to be accessible on both computer and tablet with the option of using assistive hardware such as eye gaze or head mouse. 6, the need for disabled access to be fundamentally part of the main program for any software to reduce issues around updates. 7, the need for more disabled people to be involved in design and making of their own technology rather than acting as focus groups for non-disabled makers. Changes in working practices. Number 1, learning and development in the disabled musician community around live coding and approaches to making music in this way. 2, the need for performers to be able to dip in and out of obligations depending on their circumstances without this being seen as negative by others. And 3, the need for live performances to be flexible, relaxed, with appropriate rest spaces and nutrition available. I'm working with the Universal Design Research Centre in Toronto to make a software system which will allow network performance from a wide range of disabled musicians on various platforms using various music programs. I will then invite the interviewees and a wider group of disabled musicians to explore the software and begin making music. The group will meet online and explore ways in which we can use the platform to make music together. Within the group, we will create a working with document for each person to outline any needs they may have around rehearsal and performance etiquette, communication needs, or group behaviours. As a group, we will then work to find a way to work which supports and respects each of those needs equally. This working practice will reflect a non-hierarchical network structure, allowing for flexibility and non-judgmental responses to requests. Thank you. Yeah. Yeah.
All right. Wow. Well, incredible technology. Any questions? Hi. Maybe come down, just get closer.
Thanks, Amber. To what extent would the guidelines be good for everyone? I've heard of disability-first design approach, where it's a way of collaborating with diverse people in order to actually improve things for all people. What do you think?
That was breaking up a bit. I didn't quite hear what was said.
Oh, sorry.
Yeah, I've heard about disability-first design practices, where and thinking about a lot of what you said would actually be good for everyone. I'm wondering what you thought about that. This is a way of collaborating with diverse people in order to improve things for the scene as a whole.
Yeah, absolutely. So the Centre for Universal Design Research in Toronto, they have a statement which I actually cut out of this for reasons of time, but I can read it. It basically says by making something work for those, oh, there it is. Including the most unique and diverse needs, the edges in the co-design process is an effective strategy to ensure a design stretches and responds to a broader range of needs. If we reach the edge, the design will also work better for the center and will be more flexible and generous. So I would definitely say that if you can make something that works for the most disabled musicians, then it's definitely going to work for people who don't have those kind of barriers. And I think it's also about a way that we interact with each other, rather than designing something and thinking, yeah, this works for me, I really like it. It's about trying to flip that and see ourselves as a group, as a network, and taking into account the fact that every individual is different and everybody is going to want to do things in a different way. The designer or the person who's funding it gets the final say, but that actually all voices are equal regarding of whether you've never done it before or whether you're a professor. You know, everybody's voice is listened to. So for me, that's a fundamental part of the way we music, and a fundamental part of the way ensembles can function, as well as just a key part of design.
Thank you, Amber. Yeah, definitely it's a question, like it's interesting because technology, the power of technology and the progress of technology is kind of informed by standardization, and standardization it's an odd word in this kind of context, no? Because it tries to make us all equal. Instead, we're trying to get an approach which is more inclusive, but how do you mediate between the two? That's the kind of...
Yeah, I mean, sort of going back into disability theory, we can look at standardization of something that comes out of the Industrial Revolution, where, you know, we're not bespoke, we're not making a spoon by hand for each person who orders a spoon. We're making hundreds of spoons, we're making millions of spoons. Spoons is an example, obviously. But then that means that decisions were made about the amount of effort that would go into making one design and how many people it would be appropriate for. And so those people on the edges kind of got squeezed out of it. And we've done this in healthcare as well. We've done it in education, where in order to standardize something and streamline it and make it more productive in terms of industrialized capitalism, there are some people that have been ignored because those people would mean that the process would be more expensive or more complicated and would add time and would therefore be more expensive. So in many ways, disability theory is an anti-capitalist way of looking at the world, in saying, actually, my right to exist within this cultural space or within our society is not determined upon whether my existence creates profit or not profit for the people that I'm working with. And so, you know, when I'm working with disabled people, you know, some of them I will have to spend 4 or 5 times as much time with as somebody else. And if I was counting my time in terms of money, I would then be phasing those people out of my work, because I would be thinking, right, I can't rack up enough hours because I'm not getting through enough people. Whereas the way I try to think of my work as an anti-capitalist approach, where we're valuing the individual and we're valuing the range of skills and experiences, and not just the quantity that we can channel through. So I don't know if that answers your question, but that's very much the dichotomy which disability study talks about, and it's kind of where I sit, is that actually I don't care about mass production. I'm interested in complexity and reaching new voices and hearing from people that have traditionally been squeezed out, because those people have really interesting stories to share, and we can learn huge amounts from them, but we never hear them. So, yeah.
All right, thank you very much, Amber. We have to leave it at this. We are half an hour late. Now we have lunch concerts as well. That's perfect. Thank you. And thanks all the speakers for this morning and the keynote. Thank you. Bye, Amber.